start in that spirit. We'll skip introductions and our opening remarks. Thank you for everyone being here, but let's jump into getting started if that works for everybody. So you have your agenda there in the package. Again, like we've done the last couple meetings, Bruce, is really following the material that was presented by DWR to the Independent Review Board. And with one additional item, we have a discussion here on the standard project flood and the probable maximum flood. And so what we're doing here is based on some of the discussion we had at the second meeting, we thought it'd be helpful to pull this topic out and just talk about those two different parameters and how they're used. And then the rest of the meeting here is material that was presented to the IRB. One of the things we wanted to try differently here is this time we actually want to have the IRB, we're going to have them move up and present first. And so we're thinking the benefit here is just gives a good overview of all the different material that we're going to talk about later in the day here. And then also lets you're right at the outset, the IRB can flag for you areas that they've had interest in or comments they had. So we think we'll try this and see how that works. So this on the screen here, just wanted to go over, this is what the IRB, DWR, what the third meeting, the last meeting, what that agenda was. And so just to talk, here's what we presented. We spent a good deal of time at the outset on the evaluation criteria and just the progress we've made in continuing to develop the criteria. And then we went through 4 of the different tasks. So we talked about the enhancing the spillway capacity as task 1, had the progress briefing there. Task 2, the operational needs. Task 4, the low-level outlet, and then task 6, the instrumentation. And then after that part then talked about the Part 12D Level 2 risk assessment. So this is the very formal risk assessment process that's being done outside of the CNA, but that process is very much linked, and what happens there is going to feed right into the CNA. So talked about that linkages there. After that, I don't know if I have a laser here on this one. It doesn't work on the TV. The comment or the final report outline. So then what we've done is we've started to outline what we picture the ultimate report looking like, which is part of the feedback we've gotten from the IRB and the Ad Hoc Group is what's the end product, what's the end going to look like, and so this is our effort to start putting something down so we can see what the format looks like, not necessarily definitely not the outcome, but what the report looks like, what the format is there. And then last had quite a bit of discussion about the comment log and developing that further. So that was the end of the first day. So that was all over a day. Then the second day, the IRB then did their deliberations and then provided the report. Wanted to go through that with you all real quickly here. So now we can transition over to Bruce and the IRB. So just to give you a little bit of content on what the context on what the IRB, what they're summarizing in their report. So, and I need to remind everybody. I think some of us have microphones, but for everyone who doesn't, please definitely use a microphone because we're trying to capture that for the video, and we'll have a microphone being passed around. So, any questions there before we jump in to the IRB's presentation?
Do these mics work or not?
What do we do to get these?
Yes, all the mics on the table work.
Okay.
And you may move them. In fact, it helps the people who are doing the text to understand which mic is being used.
Are they taped here live?
They're taped so that everything's on, so nobody turns it off, so all the mics are on.
So they can't whisper to each other. They're finding out.
We do have a guy actually out there turning down. All right, good morning. Is the sound working all right for this month? Okay. Yeah, okay.
The sound won't be amplified.
No, but I just want to make sure they're able to get it. Okay, very good. So Independent Review Board meeting number 3. As John said, we got together back in December, and so let me run over some of the recommendations that we have from that. One of the things I do want to do is it was ordered to where we talked about the comment log last. I'm going to talk about that first because really it's a review of the recommendations from prior IRB meetings. So we'll run over those real fast. Just as a quick reminder, the IRB members, Betty Andrews, Dr. Mejia is actually working on the Part 12 project right now, so he's not with us today. Myself, Paul Schweiger must have gotten tied up and will join us when he can get here, and Dan Wade from the city of San Francisco. So we'll move right into the past recommendations. So we term these the past recommendations. I think the project team is commonly calling this the comment log, which I think kind of fits with FERC's terminology. And so let's talk about, we were given the comment log and we were given some proposed statuses for the different recommendations, and it was basically open or closed. And we thought that wasn't real descriptive, and so we wanted to make sure that we could ensure there's a common understanding of what the status is of each of the past recommendations. And so we wanted to add some refinement to that so that DWR would actually be able to kind of show a little bit more of where they're at in terms of progressing with addressing those comments. So we came up with 6 descriptors that we're using. First one being that it's under consideration. So this is generally once we've made the comment. If they've not yet either said we're not going to address it or come up with a plan for addressing it, then we just call it under consideration. Then we have a status of planned, where they've actually identified how they're going to address that recommendation, but haven't in earnest begun doing so. In progress is when we see evidence that they've actually begun the process of addressing the recommendation. When we see enough evidence to believe that the recommendation's intent has been accomplished, we'll call it closed. If we get a comment that the team just couldn't figure out how to deal with this within the scope of the CNA, that one will get labeled not adopted, and we'll expect DWR to provide an explanation of why. We don't expect very many of these, but we wanted to leave that possibility open. And then finally, a category that's really for us on the IRB is if in seeing the presentations, we actually decide that we'd like to slightly modify what we had recommended previously. We'll have a status of superseded so that the prior recommendation can be set aside and we can give a new recommendation that we think is more focused on where the CNA ought to be going. So let's just review real quickly what the status from the first 2 IRB meetings are. Meeting number 1, that's not working too good. So at the bottom there, meeting number 1, we had 22 recommendations. All of them have been planned or are in progress. 4 of them have actually been closed, and one of those recommendations we have in fact superseded in IRB number 3. IRB number 2 had a total of 14 recommendations. There is one that's still under consideration. It's a somewhat difficult and one to address, and it's going to take some engineers at DWR or their consultants to think about, but it really has to do with the reliability of the Hyatt power plant, and the question being that that power plant is so critical to being able to evacuate the reservoir that what happens if you could not deliver power into the grid, that there's somehow a failure on the grid and you have no way of dumping the power. Without being able to dump the power, you can't run the turbines more than a speed no load, and that's not a whole lot of water coming out of the turbines. So those are some of the things, that's one that we asked them to look at. Is there a way to create an artificial load where the power could be consumed here on site in order to allow the turbines to spin at full capacity? So that's the one that they're still thinking about. They've got 9 of them planned, 3 in progress, and 1 actually already closed. So that's the status of where we're at on the past recommendations. So some new recommendations based on the actual presentations that we saw in meeting number 3. The first question to us was, do we have any recommendations or comments on the evaluation criteria? First of all, we think that they've had a very thoughtful process and have been very deliberate in trying to satisfy what we asked for in terms of setting the evaluation criteria early in the process, so that it would be out there, it would be in the open, everybody could talk about it before it gets to the end and it becomes looking like, well, maybe the evaluation criteria was evolved in order to pick a particular alternative or something like this. I think this just adds more credibility to the process to have it done early on. We're very pleased with the fact that they've selected their asset management approach. This is an existing approach that they're using already to evaluate different alternatives from an O&M perspective. And we think that it has a very good foundation in which they can use it to extend it to dam safety considerations. And quite honestly, much of the evaluation criteria will look very similar to what they're already using in asset management. So we think that that's a good basis in terms of the direction that they're going. We recommend some further development in the near term. We think there need to be a few more consequence outcome categories and just encourage them to keep moving along. It's a very fast-moving project, and so we just encourage that continue. We'd also like to see that there be some outcomes in terms of the benefits of the project. That everything isn't necessarily a negative when it comes to dam safety. There are some things that you can do for dam safety that would actually enhance the benefits of the project. Second question was, do we have any recommendations or comments on the task briefings? So we received briefings on, I believe it was 4 of the tasks. So we have some general comments, and then we'll get into the comments on each of the tasks in the next slides. So in general, you have a project where you have lots of people working on that project on each of the individual tasks. That becomes a challenge in terms of getting everybody to use the same terminology. And so we're just asking that the project integration team work on working with each of those tasks and their task leads to be sure that everybody's using common terminology throughout. We also want to see the notion of issues expressed clearly and really focus on the objectives of the project and the outcomes. Many of those were more focused on the process itself. We think the process will take care of itself, but that the focus when we start talking about issues should really be on the outcomes that we're trying to achieve and the objectives that we're looking at. And then we'd also like to see establishing a minimum set of hard constraints. There's been some language that I think David Ford can correct me if I don't get this right. It's a hard word to say and why we don't like it. Inviolable constraints and violable constraints. In other words, constraints that can either be violated or not violated. And I think one of the things we're looking at is that a true constraint is something that just can't be violated. If it can be violated, then it looks really more like an objective in the evaluation process. And so we'd just like to see kind of a clear set of what are those things that just cannot be violated, so that everybody working on all the different tasks understands exactly where the hard boundaries are. And then finally, in terms of a general comment, just establishing a common format for the tables of issues, objectives, and constraints. There were some differences as we went from one task to another on how those were being treated and used. And so I think with some review by the project integration team, I think they can bring all of that into a common format and get some consistency. So if we look at task 1, this is the alternatives evaluation to restore spillway design capacity and to pass the probable maximum flood. Our first recommendation is to really revise the title of that task, because this really isn't about just restoring the spillway design capacity. That's really already been done. The real question is whether or not that's adequate given the new PMF that has come out. And so we think the better title for it is Evaluating Measures to Enhance Spillway Reliability and Resiliency. And so that, I think, is a broader description, and I think it's more descriptive of what they're actually trying to accomplish. The second recommendation we have is to consider aligning the notion of the design flood with a document called FEMA 94. It's called the Guidelines for Selecting and Accommodating Inflow Design Floods. It's put out by FEMA. FEMA's not a regulatory body, but what they do is they try to put together documents for dam safety that help dam owners comply with the requirements of the various regulatory bodies. And so this is a document, I think it has more to do with using common terminology that would be well understood throughout the industry. I think that DWR has gone through the process. I think they're headed in the right direction. It's just that their labels can be confusing for folks who aren't inside the DWR organization and don't have experience with the terminology that they've been used to. The third recommendation we had was to establish some performance standards for the flood control outlet and for the emergency spillway. I'm going to set aside the term emergency spillway because in the general industry, an emergency spillway is a spillway that is only there for a true emergency. It's never intended to actually be used as part of the routing of any of the design floods. And so I will refer to it as an auxiliary spillway. And then lastly, on the auxiliary spillway, you've done a lot of protection from the crest downstream to the cutoff wall. There's still quite an area beyond the cutoff wall that we think it would be wise to understand what's the geology and where do we have gaps in the data about that geology to be able to get some sort of a concept of is there additional work that needs to be done in order to ensure that flows through that spillway wouldn't either jeopardize the spillway or jeopardize other operations by depositing large amounts of scour material into the river channel downstream. So task number 2 focuses on the operational needs assessment. So what we recognized here is before you can really talk about what you're going to do to alter the operations, you really have to have considered the issues from all of the other tasks first. Because until you have some idea of what measures you're looking at for the spillway, for a low-level outlet, for those types of things, it's pretty difficult to step into talking about how would you alter the operations if you don't know what it is that the infrastructure might actually look like at the end of the day. We also made a comment, there was and this might be more semantics, but there was some indication that maybe not everything that's been changed since 1970 would be incorporated into the operational procedures. And so we had commented that any physical changes that have taken place to the facility since 1970 ought to be incorporated into the operations plans. I think that's always been the intent of DWR, but we just thought it would be very good to be very explicit about what's being incorporated as they consider operational changes. And then the third one is to just consider a strategy for addressing climate change. They did this in the Central Valley Flood Protection Plan update for 2017. And so we think that that provides a good basis for moving forward with a similar approach that would be a credible approach to addressing climate change in the CNA document. Task number 4 is the alternatives evaluation for the low-level outlet. One of the things here that we wanted to see was a little more definition when they're identifying measures as to whether those are to directly achieve reliability by somehow modifying features. So for example, you might actually make some changes to the mechanical equipment or to the control systems that would actually make those systems more directly reliable. Or you could do so through making changes for redundancy. So a reliability through redundancy would be add another outlet so that if something goes wrong with the first, you've got a backup. Or add another spillway. If something goes wrong with the first, you have a backup. So we just wanted to be sure that the measures kind of got classified according to that approach. The second bullet is there was a lot of reference to requirements by the regulatory bodies, and we thought rather than focusing on doing it because a regulator says to do it because of what you believe is good engineering practice, and let that be the center of discussion, because the regulatory bodies are really just trying to enforce good engineering practice. And so we think it's better to start with good engineering practice and then have those discussions with the regulatory bodies as to why you're going the direction you are. Objective T43, this relates to low-level outlet capacity. We kind of thought that it would be worthwhile adding the words "and flexibility," that it's more than just adding additional capacity, that there may be benefits in terms of also having additional flexibility for how you make releases from the dam. Then the other thing we noticed in the alternatives evaluation for a low-level outlet is that there were lots of assumptions related to the evacuation analysis. And so we just think it's really important to document and verify all of the assumptions that are going into that. And I think that's just a matter of we're still early in the process for doing the analysis and evaluation. And so a number of assumptions have been made, but along the way, we need to make sure that that all gets documented. And then finally, some of the measures to address low-level outlet capacity may involve construction of some really difficult structures. So let's say you want another low-level outlet, you might have to tap the reservoir with a tremendous amount of head. And so that would introduce its own set of risks that would come with that. So we just want to be sure that as they go through the risk analysis, that they're also considering what the construction risk is, not just, what's the risk associated with the end product. There's an intermediate or a number of intermediate steps as you're doing the construction that would have their own risk associated with them. Task number 6 relates to instrumentation and monitoring. So what we saw was that there's a tremendous amount of effort that's going into collecting up all of the instrumentation data for the civil works. We think that that needs to be expanded to say, what are we doing to monitor the mechanical and electrical systems that are critical to the operation of the dam? You need to know that gates are going to operate when they need to operate. You need to know that you can rely on the power plant to discharge through the turbines. And so what monitoring is taking place? My guess is there's a whole lot of monitoring that takes place in the power plant just in terms of normal operations. And so just documenting what's being tracked would be worthwhile. And then what's done to monitor gate operations on the spillway would be good to have that information also. The other thing we wanted to see expanded was to expand the scope to include visual monitoring, because any monitoring program for dam safety is a combination of both instruments and visual, because there are an awful lot of things that we can detect just because we visually notice a change at the dam. And so making sure that we've got that set up, letting the operators know what should they be looking for, and identifying those records of what is or isn't changing is pretty critical to catching things before you would ever have instruments in place to formally track it. And then finally, there's been some discussion of doing more of a forecast-based operations model. And we just want to caution that in going forward with that, you'll need to have some sort of a protocol in place for when you lose communication with the instruments that you're counting on to be able to do that forecast-based operation. Because what tends to happen is you get a very, very large event. You may be counting on USGS stream gauges upstream that probably already got washed away long before you got to the most critical part of the flood. And so what's your protocol going to be when you no longer have that data flowing into your model? All right, so question number 3 was, does the IRB have any recommendations or comments on the Part 12 Level 2 briefing? Quite honestly, we think it's headed in the right direction. As John said, it will feed the CNA study, even though it's a process that's really separate from the CNA study. In essence, what it's going to do is it's going to create the baseline risk from which everything will be compared. So the process that they're using, we feel good about because it's been used within the federal sector for the past 20 years. So there's a lot of, I won't say a lot of people, but there are a fair number of people who are very experienced, which kind of leads to the third bullet, that the proposed facilitators, the subject matter experts, their recorders, reviewers, they all have substantial experience in both dam engineering and risk analysis of dams. So they've put together a good team to be able to do this. Then finally, they talked about how they're partitioning the risk evaluation and risk analysis. The project is complex, and we think that how they've partitioned that seems to make a lot of sense. So we think all of that will be able to be brought back together to have an overall picture of the risk and be able to make reasonable decisions as a result of that. Question number 4 was, did we have any recommendations or comments on the final report outline? I think what they've put together in the way of an outline is very good. We appreciate that. The one area that we would like to see more on is in the appendices that are for the individual task reports, so that we can begin to see what those task reports are going to look like. And so that was the one area that we'd like to see it expanded. We also suggested that there be a section to describe, any significant modifications that have taken place to the dam over the past, 50 years. And then add a high-level description of project motivation, approach, and report organization to really give the context for the report. And then finally, just document the rationale for the 6 tasks. I know you all have had a lot of discussion about why the 6 tasks, and we think that there just ought to be someplace in the report that really articulates why it was that those 6 tasks were selected as the primary focus of the study. And then consider adding descriptions of how and why design practices have changed since 1969. Really, this one is more about helping other people who might read the report understand the context of how dam engineering has changed. And so having a little bit of discussion, not necessarily for all dams, but those things that have changed specifically related to embankment dams, spillways, the kinds of infrastructure that are right here at Oroville Dam. And we already talked about the comment log earlier. And then any other recommendations or comments, I think our only other thing is just we were trying to identify what are we looking for in IRB number 4. And so we're hoping to see some updates on schedule progress, the initial results from the level 2 risk analyses, which are beginning this month, and then definition, or better definition of issues, objectives, and the constraints tables, and a final draft of the evaluation framework we're hoping to see by the time of the next meeting, and then outlines of the task reports contained in the appendices. So that's the quick and dirty from our report. Questions? Rune?
Is this on? Do I get a thumbs up or something from someone? Let's see, can we go back to, I think it was your second slide in the presentation? It'll get your thumb exercise in for the morning. No, sorry, it was right after the table that had a summary of the comment log.
Ah, okay.
Yeah, okay. Right there.
Yep.
Next one, sorry.
Okay.
The one that, oh yeah, here we go. Okay, so question for you. I have to give props. What I see here is kind of a process improvement, right? Where we kind of started with one thing and it's adapting and modifying. On this slide here, which now we're in January of 2019, the top bullet item is common and consistent terminology. When I go back to the July memo from the IRB, it was question number 4. Basically, response number 1 was the IRB recommends that an effort be undertaken to define a common understanding of the terminology to be used across all tasks. If you take one, or go back to the summary table. All right, so you talked about recommendation status categories. I guess the concern that I have is that some of these comments have a time relevance to them. So if you don't do them early enough, then it's kind of a moot point and it doesn't really do anything to improve the process. Is there a way we can either map these comments onto various tasks or include kind of the time element, the time relevance to the comment and whether or not it has been adopted or not adopted?
So I believe that when you see our report, which it may already be posted, I'm not sure, we actually have the comment log, and while this is just a summary, you can go back and see exactly which comments are in progress or closed. I don't recall right off my head on. Oh,
yeah,
okay.
So Bruce, the comment isn't, is it open or closed or what's the status, but it's, this comment is really only valid if it's applied at task 1. We're on task 4, so why is it still being considered?
So I think, first of all, give credit to DWR and their consultants for having made progress on this. I see far more consistency in the terminology that they're using when we had meeting number 3. However, there's still room for improvement, and I would anticipate that this comment may actually stay open all the way through the draft report in order to make sure that there is just absolute consistency throughout the report as though you're hearing it with one voice. And so it's a product of DWR, and our goal is to try to help DWR provide a report that you all can read and not be confused by the comments. I don't know that they can forecast right now all of the terminology that's going to be necessary all the way through the report, but I think that your comment is exactly what we're trying to do, is give them the encouragement when we see these differences for them to be encouraged to resolve those differences as quickly as possible.
Sure. So just to clarify, my comment was not specific to terminology, though it's just an illustration.
Yeah.
But some of your comments do have a time relevance to them, and can we include that time relevation or relevation into the status, right? Is it kind of past the point of being a useful comment, or is it still in the cards of being a useful comment?
I don't see why we couldn't, in the next meeting, add a column to
And
indicate a target date for completion.
On the note of the glossary, we talked early on about having kind of a running glossary. So as you come up with terms and whatever the definitions are, we'd have a place where we can go. You mentioned several times in your presentation, as I'm using the word, it means this.
Yeah.
Is there a place we, as kind of the ad hoc committee, can go to get some understanding of how you, the collective, are using various terms?
Rhonda, have you included the glossary in the outline, or is?
I do not know if this group has received the glossary, so we are helping out here. Sergio, have you handed out the glossary?
The glossary has all that.
Okay.
We can do that at the next meeting.
So it sounds like that's an action item for the next meeting.
We could get it out to the rest of the group after this meeting.
Yeah, I think that would be good.
That's a very good point. I mean, I
Yeah.
think if we're not agreeing on the terminology and getting that clarity early on in the process.
Yeah, and last time we had a discussion, I think Joel, it was with you on kind of effective risk communication. And having some understanding of how people are using terms is kind of a fundamental first step to having effective communication. I think that's one thing that we're striving to do here, especially with this group, because there's so many different perspectives and backgrounds. And so in order for us to have engaged, effective communication, we kind of need to have a common starting point. So while DWR and the review board may have shared terminology, if that doesn't extend out to this group here, it makes it very difficult for us to have that engaged conversation as well.
Good comment.
Yeah, I think that's, I like the idea of getting the glossary out earlier, and I'm sure will grow and change as we move through it, but.
Well, you could even have that be a link on the website. And as you update terms, they go there and it's kind of a living document.
I had a couple questions.
Yes, sir.
So one is,
Sorry, excuse me,
Oh.
I remember. Would you just move the mic
I
away?
think he's.
I have my mic'd up.
He's mic'd up.
I guess that's one of the benefits of being the co-chair, I guess. You mentioned in here that you note that the DWR has turned to their asset management framework
Yes.
as the basis for assessing risk, and you say that as a positive thing. So, I mean, I guess I'm taking from the IRB that you think this is a good metric to use.
We believe it's a good fundamental framework to start from for their evaluation process.
Right.
And you'll hear more about it later this
And
morning.
so
from
one, I
David
just want to
Ford.
tag that because I'd like to know more about what does that entail. And I would just propose the question was, was asset management framework used over the last 40 years? And, obviously there were things that were missed that led to the incident that we're all here for. So, how have we has that framework changed and been adjusted so that we ensure that we're fully evaluating all the risks?
So my
It's
suggestion would be.
kind of an open question there,
Okay,
right?
so let's leave that question for when David Ford gives his
Okay.
presentation on
Perfect.
the evaluation criteria, and that may illuminate it or may help you focus your question even more.
Right. The other one I wanted to ask about was, you note in here that in changing the title of that task 1, that the latest PMF hydraulic analysis appears to indicate that combined discharge capacity of the FCO and the emergency spillway have adequate capacity to pass the PMF with freeboard. We're going to get to that in another presentation, I know. But then you say the current spillway system may in fact meet or exceed accepted industry standards. Like, don't we know that it does or it doesn't at this point? Can that be stated? Like,
So
the spillway's been constructed, I'm assuming,
it has been.
to exceed standards, but has there been an assessment that that is
So-
the case or isn't the case?
So understand this, the chute, so downstream of the control structure has all been updated to current standards or to exceed current standards. The control structure itself has not yet been addressed, and that's actually task 3. So
The gate, the head.
the gate structure.
Okay.
And so the other piece of it is looking at the reliability of the auxiliary spillway. How much do we know about that? Do we have the confidence? And so those are the things that through the risk analysis, when we see the results of the risk analysis, we'll have a better sense of whether what's been done to date is sufficient to bring it up to what we believe is an appropriate in terms of a minimum level of risk.
Okay. And I agree that the recommendation that you have on, at least on the auxiliary spillway, is, hey, we need some more data, geological data downstream of the secant wall. if you will,
We at least
downhill
need to
of the
understand what our gaps are.
secant- Right. Okay.
Assemblyman Gallagher looks through his notes.
I think that was all I had. Any other questions from members? Yeah, go ahead, Rune.
So one of the questions, this gets to the metrics, and I know that there was a partial response. During our July meeting, we talked about safety and reliability, and how do you articulate, when you say safety, what is it that you mean? What are the criteria, the metrics that you're evaluating to say, yes, it's safe, or no, it's not safe? And my request was, can you provide explicit metrics? And the example that I gave was, in this room, there's a sign above the door that says occupant load 51. Well, that's probably how many people at the max you should have in the room. I'm not sure that I've seen any similar type of metrics emerge out of this whole evaluation process. I presume that they're in there buried somewhere. But is it possible to get some sort of a listing? And again, this is kind of in line with the glossary notion, so that the ad hoc committee has some idea of when you say safe, when you say reliable, we have some idea of what the spectrum of metrics that you're considering are. And we understand that there's security and you can't divulge everything. So we're happy to kind of work with you on that. But stating metrics and kind of what the measure is seems like a fairly safe thing that you can do without divulging the inner secrets of all the analyses.
So what I would suggest, let's wait for David Ford's presentation. And I think that this is an area that the IRB is still anticipating seeing. This is why in our last slide where we talked about what are we looking for in IRB meeting number 4, is we'd like to really see a final draft of what the evaluation criteria looks like. So that we know what is it that DWR wants to use as those metrics.
So, but again, this goes back to the time relevance, right? I mean, if we're starting analyses and we don't know what the criteria is, there seems a little catch-22 built into that process. And as I look up on the screen, to me, this kind of looks like a leading indicator for organizational decision freeze, where we've got all these things we have to make decisions on. It's too hard, yet we have a schedule to meet. How do we mix all those and make forward progress? And I think here's where all of us have to kind of roll up our sleeves and work together to prioritize, shuffle the stack, and say, hey, this week, this is the most important. We need to focus on this so we can move on to the next step. But if everything's important and everything's in planning and you're moving through the process, you're going to skip a lot of stuff that's very important down the road.
So I happen to agree with you, and I think the board agrees, and hence why, even though we already had a recommendation to get the evaluation criteria established early on, we re-emphasized it in this report again to establish that this is an urgent matter that needs to be addressed quickly.
So we can use your table as a gauge to see how we're doing, and as the IRB numbers increase, we should see less entries under consideration, planned, or in progress, and more down on the closed or not adopted or superseded side.
I would certainly hope to see that. That would be a great indication of progress. And it's why we wanted to have more refinement rather than just open or closed, is you'll begin to actually see some progress sooner than what you would see if we had to wait for everything to be closed.
And I think if you tie in the time relevance, that's helps shuffle the stack, right? I can't move on to task number 2 until I get all these other things cleaned up.
Yeah, and quite honestly, though, I think it's a complex project. There's a lot to be done. I think they're doing a good job of working on as many things in parallel as possible. And I think it's not everything is going to be linear.
Well, I guess what I want to caution is something that this group can bring to the table is staying away from what we call E3 errors. and that's solving the wrong problem precisely.
Yeah.
And so there's got to be this give and take where we're being responsive and appreciating the uncertainty, right, context that we're in, and making sure that we stay focused on what's the most important, what do we need to put our energy in, and it has to be that safety and reliability component. That's why we're here.
So my only caution on defining safety and reliability is there will never be a precise number that will define safety. I don't think any industry has found that.
That's right, and I'm not asking for a number. I'm not asking for a definition, right?
Just what the metric
We're looking
is.
for a portfolio of, from these different perspectives, this is how we're looking at safety. But the challenge is that even that first step doesn't exist now. We have no idea. We just hear the word safe, we hear the word reliable, we hear the word risk, which is even more ambiguous than safety or reliability. And how do all those kind of fit together?
Yep. David, are you taking this all in? All right, very good.
Well,
Also appreciate how you set me up here.
Raising expectations.
okay.
All right, other
Any other
questions?
questions? Yeah.
All right. Oh.
More in the nature of a comment. The IRB's recommendation to change the description of task 1 is evaluating measures to enhance spillway reliability and resiliency. You've, I think, legitimately changed the exclusive focus on essentially capacity to meet a PMF. And I think that your recommendations may get at this in more than one way, but I think perhaps a better way to say that is evaluating measures to enhance spillway competence to meet project objectives, reliability, and resilience. Project objectives presumably means meeting the PMF. It very well may mean avoiding large deposition events that cause havoc to project operations and may make operators fear following their procedures in the appropriate circumstances. So I think that the competence to meet project objectives is perhaps a more precise and expansive and clear way of saying what I think you're intending to say.
So I think DWR would certainly entertain a suggested revision coming from this group.
That goes into the under consideration column.
Pardon me?
That would go into the under consideration column.
So if I were to add a column for IRB number 3 right now, you would have all of them. I think there were maybe 12 recommendations, if I remember right. All 12 would be under the under consideration status.
Okay. All right. Well, why don't we move to the next portion of this then?
Okay.
On the,
Thank you.
Yeah.
you,
Thank you
Chris.
very much. Yeah.
All right, while John Lehigh is getting set up here, I just want to say, so we didn't this time put a big block of time at the end for questions, because we thought the last 2 meetings it was more effective to have questions come in as we go. So while we're doing this presentation, this is where we're also expecting, as you guys have questions, please bring them up, and I think that'll be an effective way to do this.
John begins his presentation.
This is me, yes. Okay, thank you. So hello once again. Good to see everybody. I think what this presentation is really about is kind of we had a good discussion, I think a good dialogue last meeting. And so I think this is sort of a follow-up to that. I think we maybe ended that last discussion maybe not completely satisfactory in terms of, I think we were kind of going back and forth in terms of standard project flood, probable maximum flood, what do they mean, what is the purpose of each as it relates to the design of the dam and the operations of the dam. So that's what I'm going to attempt to help add some clarity to today. if I'm unsuccessful and there's still some confusion, I'm just going to defer to David Ford's presentation. So, just joking, David. Okay. Before we get started on, to talking about the design floods, we have the standard project flood, which is really designed for downstream protection, probable maximum flood to avoid overtopping of the dam itself. Okay, so those are kind of I'm going to repeat that a few times so that we can get that basic understanding down. But before we go into that, I'd like to talk a little bit about the flood risk reductions that the dam is providing. And I have a facility there for 50 years. I think we kind of forget what did the system look like prior to the dam being there, and what would the flows look like on the river absent the dam. So I'm going to go a little bit into exactly how does the dam perform those flood risk reductions. So very simplistic diagram here, but the key is what's that? Yeah, sorry. So the key to the flood protection is the flood space or flood reservation that's held in the dam itself. So this is the original investment by the federal government was the 750,000 acre feet of vacant space to absorb the very large storms, so the effect of those floods would be attenuated by the dam itself. So that's about roughly a little over 20%, and that varies depending on the conditions in the watershed, how wet it is, but essentially that was the original investment in terms of flood protection. So this is the result. This is the attenuation effect that you see. You see the very large inflow events that come into the dam. Those are absorbed by that space, fill it up to a certain degree. The bigger the event, the more of that space you're going to fill up. But that allows for operations to release that water in a much more manageable rate that does not, in the case of the standard project flood, at a rate that does not exceed the downstream levee capacity. So that's the design. That's what the design for the flood protection is all about. Let's look at some of the historical floods. We can look at pre-Oroville, so 1955, big flood, devastating to the area. And so without the dam, we had, in the upper watershed, we had well over 200,000 CFS. There was no dam there to provide that attenuation. That continued on downstream. Of course, there was heavy loss of life. Yuba City completely flooded that year. The dam started construction late 50s, really well underway in the mid 60s and completed in 68. But again, part of the design here was the standard project flood is that 440,000 CFS inflow. And so the purpose, the design of the dam and the location and the capacity of the flood control outlet, the gated spillway, was then to be able to limit the downstream releases to about 150,000 CFS. So that would stay well within the downstream channel capacities. During the construction in 1964, we saw another big event. The dam hadn't been completed at that point, but it was still enough enough of the embankment had been put in place. We had the diversion tunnels were fully functional at that time. They were diverting the river around the construction site. We saw an event, 250,000 CFS, which was actually larger than the 55 event. But the outflow was actually attenuated down to 157. So that certainly already, before the dam was fully constructed, was providing some benefits there. And then we have the big events after construction of 86 and 97. So you can see 86, we had a large event, 266, 150 out. The 97 flood, this is the largest flood on record since the construction of the dam was well over 300,000. Those are the largest inflow events that we've seen at the dam. And you can see closer to 150, 160,000 in that particular year. And then last year, you can kind of see how that rates to, well, 2017 now, how that rates to the other historically large events. It was one of the larger events, but certainly not nearly as large as some of these other. 190,000 CFS in at the peak, and with the spillway in the condition it was, 100,000 out. So again, significant attenuation occurred that year as well. So this graph here will just give us a feel for the relative magnitude of these events, not only in terms of, and these are the hydrographs for some of the events that I just went through, both in terms of the peak flow rates and also the volumes of these floods. So the very lowest one there in the yellow, that's the 2017 event. Was a big event, but on the scale of some of these other hydrographs, it's not the largest. In the gray there is the 1997 flood on record since the dam has been built. And you can see that it was not quite, but almost close to twice as big as the 2017 event. Now, the red here, that is the standard project flood that I've been referring to in terms of being able to, it's a theoretical event. We haven't seen that event, but that's the design flood in terms of managing the downstream flows, not to exceed those channel capacities. Now, the probable maximum flood is what you see in blue. So the red is something that the standard project flood is a flood, theoretical flood, that's characteristic of this watershed, and there's certainly would be some likelihood that it could occur during the life of the dam, and so that's the standard project flood again, which is the red. The blue is the largest flood event conceivable, and the probable maximum flood probably should be called the improbable maximum flood, because it's like I said, it's a hypothetical in nature, but it is all about the spillway design. The dam needs to be able to pass this event without overtopping. So that is the design purpose of this probable maximum flood. The downstream would be completely inundated during such an event. But what the purpose of designing to this event is to ensure that the dam stays up so it can fight another day to continue to provide its flood protection moving forward. But so that's kind of the key between the two different events. One is about the downstream protection, prevent overtopping of the levees downstream. The probable maximum flood is about avoiding overtopping of the dam itself. So that's the distinction. So again, this is just a little bit of what I've just gone over. Standard project flood is what the Corps used for their initial investment in the flood protection. Recurrence intervals, so this is important in terms of risk. 200 to 500 year event is typically what these standard project floods are. So there is a slight chance of it occurring over the lifetime of the facility. And it's all about the downstream levee protection. The probable maximum flood or improbable maximum flood is the worst flood conceivable. It's not really statistically based. It's all about what is the largest event that you could conceivably, given the physical properties of the watershed, what could actually occur. If you had to put a recurrence interval to it, it'd be something along the order of a 10,000 plus year event. And again, it's used for spillway design and prevent overtopping of the dam. But it's clear that downstream flooding would occur in this type of event. I mean, it would likely, this type of event, it would be a regional event. Every tributary in the entire system would be absolutely out of control in terms of flooding. So, so anyway, I think that's all I had. I think we might have a little bit of time to entertain some questions on that.
Ruin.
Can you go back to your hydrograph slide? It's more of a comment as opposed to a question. So when I look at this, I kind of look at the blue line as bracketing the uncertainty bound, maybe a factor of safety. So on kind of the extreme end, the structure's got to tolerate that sort of a load.
Right.
On the other extreme end would be there's no load at all. And then kind of your best guess is your standard project flood, which is the red line. That's kind of your average or your target. So when we look at these kind of risk analyses, there has to be some degree of uncertainty in terms of, well, I don't know exactly what it's going to be, but I'm going to build in, whether you call it robustness or whatever. But that's kind of illustrated with these curves here. So that when I look at this thing, that's what I'm seeing. The other thing that I'm seeing is that the reliability of the structure has a time dependence to it. So it's not that once I build it, it's always going to have this level of performance, because I look at 1997, which is the gray line, and it had a higher ability to withstand a reservoir pool or whatever you want to call it, relative to what happened in 2017. So as the process moves forward, my takeaway from looking at this plot is that the risk analysis needs to have some sort of aging or time dependence or something built into it, so it's not one snapshot in time, this is the reliability of the structure, but we have uncertainty associated with time in there as well that can then bracket what the actual reliability of that structure is over whatever the operational period of the structure is over the next 10 years, 50 years, 100 years. Because coupled with that, you also have uncertainty in loads, your inflows. Some people believe in climate change, some people don't, but that's going to have an impact on the certainty of the loads that structure is going to see over time. And what you'd expect to see as you go out into the future is that uncertainty band's going to get bigger. So that's just a comment, not really a question.
Yeah, okay. All right, thank you. Yep.
So John, I do have a comment on that. Perfect. So I think, having done lots of these studies, trying to forecast what the condition of the structure will be in the future is even broader in terms of uncertainty as to what you can expect. I think this is the reason that we do cyclical evaluations of these structures. It's why FERC has a program where it's evaluated every 5 years. And so you get that time dependence by evaluating the condition of the structure every 5 years and saying, it's not just one point in time, it's a series of points in time where you do that analysis. And so that's how you take the time dependency into consideration.
Sure, so that's a valid point. I think that's an appropriate strategy. So you'd have to build that into your risk reduction and mitigation process. Every 5 years, I've got to go back, and I know from the U.S. Bureau of Reclamation that there are different dams get different degrees of attention depending on different symptoms that have occurred that may or may not question the basic assumptions. And one of the questions that we had, which I don't think we've gotten a response to yet, was the independent forensic team highlighted that there were deficiencies in the methods employed to do some of these risk analyses. What updates or revisions have been incorporated, maybe this is one of them, that would kind of speak to some of those deficiencies so we don't end up in a situation where we do an analysis that's not representative of what we have out there. And how can we build in some verification and some checks that serve as a double check, if you will, that the assumptions that we have are real and being manifested by the structure that's out there. So again, more of a comment, but as we get into the Part 12D or whatever the process is going to look like as we get into the more formal risk analysis, I think these are some of the fundamental questions that this group has an opportunity to confront, and not that there is an easy answer, you just pull it off the shelf, But again, let's roll up our sleeves, work together, and get at some of these things. Let's employ some of the techniques. But can we also think of additional techniques we can use to convince ourselves that we're solving the right problem and getting at the right answer, as opposed to just doing an analysis, saying I'm done, and then moving on? You're going to comment, not really a question.
Hey, John, can I kind of add, and I think, and Bruce, maybe you guys can confirm if I'm correct, but the forensic report talked about that they were happy to see that the department had started updating our asset management to the ISO 55001 standard. So we've had an asset management program since the beginning of the State Water Project, but we're updating it to an international standard. And I believe the reason they made that comment is because of your question, which is when you have a framework on asset management, it tracks the asset from being built, the whole complete life cycle of it, and therefore it's going to have what those plans are, you know, any updates like climate change. In the life cycle of asset management, you would reevaluate those conditions and then the service level of the infrastructure, and then make decisions on are changes needed. So that I think is why I think the forensics team, and hopefully you guys agree, is another way of trying to tackle what you're talking about, making sure the asset is kept.
And I think the point that Rune is getting at is, we're talking here about what's this designed for? Well, we designed for the standard project flood and for the probable maximum flood, right? Or the improbable, right? Right, we designed for that standard, right? But when we design that, we're assuming that everything on this facility works exactly as it's supposed to, right? Mm-hmm. And I think what Rune is getting at is that, hey, but there is an aging factor, right? And that, I'm not saying that that wasn't built into a framework, right? But obviously there was a slip somewhere, right? Because we had an event that wasn't anywhere near what we have experienced, and not everything on the asset worked the way it was supposed to, right? I mean, I think we can all admit that. And so how do we make our framework and our ability to keep time with a structure, how do we ensure that that's really making sure that this is always going to perform according to what we designed it to do, right? I mean, I think, and yeah, that's in progress of being done, right? But whatever we had before obviously didn't catch it on the flood control outlet, right?
Yeah, but I think, yeah, I agree with you, and I think this is why we're doing this, and the industry's involved, just like our audit that we just did through, you know, was with other industry leaders, and that's why I think this is something that's getting pushed forward into the industry. I don't think it's common that the asset management framework like that, the dam safety program, is all embedded. I think that's all the learning of what's happening after this event. So I think we're starting to push the industry into a better place by doing that, but I think your points are well taken.
And like, this is a bigger theme across a lot of things. Our infrastructure assets are getting old.
Yeah.
Right? And when they get old, I think there's a corresponding risk factor that goes up too, right? So how do we make sure that we're addressing, I think we're going to face this across the board.
Pipelines, roads.
And that's kind of one of the things that keeps me up at night. But I'm sure it is you too.
If I can just, I want to put out a caution when it comes to looking at international standards or this thing and that thing. We have had direct experience working with some of the utilities on the West Coast that after an incident moved towards, we're doing ASTM, we're doing asset management. And what you find is that isn't 100% of the answer. That's part of the answer. But being mindful and being diligent and being focused on what is it that we're trying to achieve is probably the most important part. And I don't think anybody has the answer. You can't go to any consultant. They're going to say, hey, DWR, here's your answer, right? Because you know your infrastructure the best. At the best, they're going to be able to work with you and kind of guide you in a direction. But adopting this notion of being mindful and being observant, and are we seeing what we expect to see out there? If not, why? Going back every 5 years, revisiting those assumptions. But if we don't have an understanding across the organization of what the expected performance is, that becomes more difficult. And that kind of goes back to the earlier comments about the metrics, right? What is safe, what is reliable? And if you have a clear understanding of that throughout the organization, that's going to increase your ability to better manage your infrastructure. I do think all these things kind of fit and work together. I don't think it's reasonable that you guys are going to have all the answers, or the review board is going to have all the answers, but I think together we can kind of work towards that notion.
So I would just add one caution on the notion of aging, that what causes risk is not the age of the dam, it's the condition of the infrastructure.
Okay.
And that's why going in and doing these periodic assessments of what the condition is gives you a time-based assessment. And
Right.
so you have to be certain, though, that what you're evaluating on those periodic assessments is comprehensive
Right.
in terms of looking at all of the various aspects of the infrastructure in a complete and comprehensive manner.
And I think that's where the forensic team said, hey, look, these periodic analyses we did were
Yeah.
not, whether they were done by the state or the feds and FERC's 12 Part D and out every 5 years, they didn't catch this problem, right?
And I think we used to always joke about it in reclamation, that it's kind of the syndrome of what's happened lately, that people become complacent when things are being done extremely well. Because nothing happens, everything works the way it's supposed to work, and then there's this pressure to say, well, why are you spending so much money looking at all of these things when nothing's really going wrong? And that's what, in the dam safety industry, we constantly fight, is that when we're most successful is when people start to ask the question, well, what's the use of doing all of this?
So to that, shifting from lagging indicators, oh, things are going wrong, or I fixed this, to leading indicators, and focusing on those leading indicators to say, hey, we're doing a good job, this is the feedback, is a mechanism that we can employ. I wouldn't say it's industry standard, but this might be an avenue we can explore for this venture here, is to address that topic through other strategies.
Right. Agreed. Ron? Oh, yeah.
This is just part of it, but one addition to the level 2 risk assessment, where traditional risk assessments have been based on an uncontrolled release of the reservoir, this risk assessment is going to incorporate the level of interest of the features of the dam performing as intended. So it's another part of all of what you're talking about.
That's going to be done as part of that 12D.
Yeah.
Yeah. Level 2, sorry, yeah. Ron?
We may discuss this when Dr. Ford gives his presentation, but just to refine John's presentation, the PMFs and SPFs were intended to be kind of a single number or a single hydrograph without necessarily having some kind of frequency associated with it. They're essentially intended to be a kind of a deterministic assessment of worst case floods of various intensities. The question then becomes, how often are those revised, and what does that mean to a dam design that may have not included any ability to adjust upward the performance of the project. Another thing we've been talking about here is the performance of the dam, but at least with the concept of floodwater management operations, the concept here in the Sac Valley is to confine the floods to the floodways, as in you shouldn't experience flooding outside the floodways, at least the formal areas where you actually expect water to stay in the floodway. The question then becomes, well, what happens if you have an assessment that the levees don't have the integrity that you thought? And an example of that is the 1997 floods. At the time that occurred in 1992 or 3, the Corps had downgraded the competence of the Feather River levee at the place that broke in 97, down to 268, I think, or 270,000 CFS flow, and the design flow there was 300,000. And so you had, the question is, how does that feed back into dam operations? And the official answer is it doesn't. But is that really the right thing? I mean, and that's kind of an interesting question, and a question that we ought to think about, and DWR needs to think about it, because you got a lot of levees downstream of Oroville. And so what's the, what does the department do with regard to dam operations if you have a known major problem downstream? And fortunately, or unfortunately, it turned out that the levees did fail. They failed at design capacity, not below that, but it was an obvious area of concern, and yet there was no change in operations up here. So that's another issue that the department needs to confront as it moves forward. Thanks.
All right. Well, I think we'll. It's a good segue. Oh, Matt, go ahead.
I got a few questions, but try and keep it quick. Could you go over wetness index real quick for us? It's like you multiply the total rainfall for the year by 0.97 and then add in the previous day's precipitation type calculation. Yeah. Where is that taken from? Because currently right now we've had like 8 inches of rain in Marysville, but we've had 25 inches up at Strawberry Valley, talking the Yuba River. So what gauge do you use to index that, or is it broken into subregions?
There's 8 different stations within the Feather Basin, so it's an average of all of those. There's eight stations.
Mm-hmm. Monthly, you're required to report out what your target elevations are based upon those calculations, correct? And during
On a daily basis.
Daily basis.
Yeah.
For the interest of the citizens downstream, is that something that could be shown on the DWR website under the Oroville page?
It is available. It's already being posted. It may not be entirely clear where it is, but we could make that more clear. At least point folks to where exactly you can find it. You can find it on our daily reports now. It may not jump out at you, but it's there.
It's not page 1.
It's, well, actually it is on page 1.
John, if you could use the mic there.
Oh, I'm sorry, yeah. So, yeah, it actually is on page 1 of, if you know which report to look at. Yeah, that information is being posted on a daily basis, and we can try to provide some better clarity on where to find that.
Okay.
Yeah.
Have you had a chance to run the numbers on Atlas 14 on how that might change hydrology? And is that 3.1 million on probable maximum coming from Atlas?
I'm sorry, which one were you pointing to? The
probable maximum.
Probable maximum. So, yeah, so that was one of the questions that we got from FERC. We've just responded back to FERC that we're going to be taking a look at that, and so we'll have an answer back within the next, I think we said 90 days.
Do you have a ballpark estimate on how that might change, say percent-wise?
I personally do not.
Would that be helpful as we are looking at dam design and capacity within the C&M process?
Well, we'll certainly, like I said, we will be looking at that, and we will have a response back within 90 days.
Yeah, because if we're going to invest $500 million in a third spillway or something, it might be helpful to kind of know what target we're shooting at for probable maximum. The other thing along those lines is that hydrology change that we're looking at through Atlas is an 8-year interval or so. You get new hydrology. You went from HMR 39 to 59 and now to Atlas 14. And we could probably expect 3 more changes during the life of the spillway, the additional spillway. So we have a contingency plan within our designs to account for ever increasing hydrology? If you look at some of the reports coming out of NOAA and Scripps Institute, they're saying that we could be seeing, 10, 12% increases in hydrology every 10 years going forward.
Yeah, so I mean, so this is an expansive subject, but it's sort of ties into what we were talking about before. How's your risk change over time, and how can you deal with that through flexibility? And I think, and so what we're being presented potentially with the climate change scenarios is we were talking about the performance of facilities, but on the other end, potentially Mother Nature is changing, right? So how do you, when you're putting in fixed facilities based on certain design criteria, how do you deal with significant changes on the upstream end of that, and the risk changes? And so, I think that's why we have to look at other flexibilities that we might have, and improvements in technology in terms of forecast-based operations is one of those that we are, we're partnering with Yuba County Water Agency, or Yuba Water Agency, on that, and because we're connected at the hip with New Bullard's Bar for these very large events. And so that's one area. I think when we do look at and we engage the Corps on a new flood control manual, I think we need to get some kind of flexibilities built in there so that we don't have to, revisit every 50 years on these very set in stone type rules, something that can adapt and take advantage of new technologies in terms of being more flexible, and how do we respond to those changes and risks over time?
All right, I want to move us, because we're getting way behind schedule here. So can we move? Because I know we're going to get into this a little bit with David Ford's presentation too. So okay, yeah. Why don't we do that? Is David next on this, or?
David Sarkeesian, we're building up to David Ford.
Why don't we? Well, I mean, you're going to be on the same topic, though, right?
Yeah, we're very connected in terms of presentation.
Okay.
I think works well to introduce.
Yeah, it's a good lead in.
Okay.
Yeah.
All right. Well, let's do that.
Dave begins his presentation.
Good morning. I'm Dave Sarkeesian, DWR, O&M, and I'm Chief of Dam Safety Services. And so this will work well, I think, as I mentioned, to have Dr. Ford expand upon how CNA is incorporating the Level 2 risk assessment. But my presentation will kind of provide a recap of the Part 12 and Level 2, and at the end, touch upon CNA. So this is, I think, common knowledge to a lot of you. FERC has a Part 12 process, which is an independent inspection and evaluation of the project works. In this case, the Oroville facilities. It's a federal regulation. It's on a 5-year cycle. And in our case, we also have a California Water Code requirement to have a Director Safety Review Board on a 5-year cycle for our state water project dams. And for our FERC licensed dams, we combine it. We basically have one board that satisfies both regulatory criteria. We do solicit independent consultants and board members through a request for qualifications process, where we advertise, describe the scope of work, we receive resumes, and then we review the resumes and interview candidates to try and build the best board we can for the set of dams we're dealing with. We also work with DSOD to review those resumes and go through that process. We do target different disciplines. Obviously, sometimes we have a certain subject matter for a group of dams that we really want to get maybe a hydrology focus or a structural focus. And so each board sometimes has a little different flavor of independent consultant or board member brought on board. In the case of licensed facilities, we submit those resumes to FERC for review and approval. So actually, this was supposed to have a little cartoon to it. But anyways, I wanted to revisit the multiple boards we have and each board's scope and purpose. So you're well aware we have the Spillway Recovery Board. That's been looking at the spillway reconstruction over the past couple of years. They're really focused on the spillway chute and the emergency spillway. We have our Oroville Complex 10th Part 12D board, which is underway. That's where Dr. Mejia is today with that group. And they're looking at the whole Oroville complex, including the saddle dams, and going to fulfill that Part 12 requirement with their end deliverable or report. And then we have the CNA Independent Review Board that's, overlooking and providing guidance on this project. All of those boards are going to participate in or review the PFMA, Potential Failure Modes Analysis / Level 2 workshop, which is coming up quite quickly here. And I added the little rectangle, the Level 2 risk analysis team, which I'll get into shortly. So since the early 2000s, FERC has required dam owners to incorporate this PFMA process. And, you know, early on, a dam owner would have a full workshop, and then FERC would allow a dam owner to just do maybe a review of the PFMs in the next 5 years. In our case, we're doing the full workshop, of course. And so what we've done is adding to the process is the level 2, and it's kind of like an add-on in my mind. And that's going to meet that recently signed federal legislation and also provide that baseline condition for the CNA project. It builds upon the PFMA by adding the likelihood of each failure mode and the consequences. And that's going to yield that estimate of risk for each PFM or potential failure mode. So just a quick update again on the federal legislation, which I've got in here. The legislation required us to go reach out to the United States Society on Dams, get a list of nominees. We did that. We contacted the nominees and inquired about their availability and interest. And that really built the independent team. And that team is tasked with preparing, leading, reviewing, and completing that level 2 risk analysis in accordance with the FERC draft risk-informed decision-making procedures. That level 2 risk report is going to inform the Part 12 board. They're going to obviously be part of that workshop, part of that process, and a lot of their recommendations will likely tie back to things they learned through that workshop. So we submitted, we had that independent team develop a plan basically, because the draft guidelines by FERC have a lot of good guidance, but they don't, there's some of the technicalities of how you run a workshop that we wanted to make sure we had dialed in and FERC concurrence on. So we had them develop a plan. We submitted it on the 26th. It had all those resumes of the individuals so that FERC could see, you know, who's going to be on this team, and provided this schedule. It includes the site visit to the facilities, which is upcoming. That's a key component to make sure all these subject matter experts and participants actually get to walk the facilities and get a first-hand look at them. And you can see that the subject matter is broken out to try and bring in the appropriate experts at the right time. And so we've got a large suite of what we call subject matter experts, both DWR engineers and consultants, that are going to basically study up on these different features and bring that knowledge into the workshop. Another thing we had our facilitators do, and it's routine, is you start soliciting ideas in advance of the workshop. So you get a bunch of information, potential failure modes in advance, and it helps the facilitator really queue up all the information and is a big time saver. So the IFT report did have some distinct recommendations for us, and for really all dam owners that's going to, you know, have a PFMA or risk workshop. Some of the ones, and there's many that were listed in the plan that we provided to FERC. I pulled out the 3 that I thought were kind of significant. Ensure the participants or the SMEs are diverse and adequately cover all relevant technical disciplines. So we spent a lot of effort doing that, looking at resumes, contacting consultants, bringing them on board, talking to the independent team about who's an appropriate expert to look at, say, you know, mechanical issues on this piece of the facility. So people have been very targeted on what they need to study and what they need to prepare for. We've also divided the workshop into those component-specific sessions. That reduces the fatigue, you know, increases the focus on the appurtenant structures, which is a big theme coming out of the IFT, and allows, once again, SMEs to focus and be present on specific dates, because we've got such a large group of people that, you know, just coordinating everybody for this whole time frame has been quite a challenge. And then the last bullet, broadening the scope of potential failure modes to more than uncontrolled release of water. So we are going to be looking at failure events that may not have an uncontrolled release of water, but there could still be a significant consequence to state water project operations or water supply or the environment. So that team will facilitate and maintain the records. We'll have about 45 to 60 people in the room. It's a lot of people, but to make sure we got things covered, that's what it's going to take. We'll have FERC, DSOD. We have some Army Corps of Engineer staff that are coming in, a geology SME and also a consequences SME that are on board for the workshop. Former reclamation engineers that are well versed in how reclamations performed risk for their program, and of course consultants. We'll have the Part 12 board, the Spillway board, our independent review board for CNA will join us for some of the components of the workshop as they're available. And then that independent team is going to author the report. So this is just a quick kind of graphic of kind of inputs on the left-hand side, things like probabilistic hydrologic hazards, life sim models that kind of give consequence estimates, updated probabilistic seismic hazard analyses have been conducted, and we have those in our hands to bring into the workshop. And then a large volume of other engineering analyses. We have compiled a tremendous amount of documentation to give to the participants so they can study and prepare. That middle box there, compiled documentation, assemble the level 2 team, we've done that. Submit the resumes and the plan to FERC, we've done that. Distributed documents, scheduled the workshops, and we actually heard back from FERC just this week that they've approved the plan, the level 2 risk workshop plan, and the team. So we're all set to go. Next up, we're basically right here. Start the workshops, and I believe it's next week are those site visits, and then weeks after that, they'll be having the workshops. On the back end, the level 2 report will be submitted to FERC. Reports will be considered by the Part 12 board through their process. That'll be a resource for them to develop their recommendations. And those reports will be used by the CNA tasks to really help to identify the needs, the measures, and also it's that benefit of kind of showing the risk reduction benefits for the different measures that are developed. This is where Dr. Ford will give you a whole lot more of these matrices, but there has been a lot of effort by the team to develop a risk matrix that helps overlay both the FERC level 2 matrix and also our own internal asset management matrix. And the idea being that the output of this workshop will be able to integrate with both those programs, because I know FERC is going to want to be able to take the risks just specific for Oroville and compare them against maybe some dam on the East Coast where they've had a similar workshop, and they can hopefully overlay maybe in 10 years the whole portfolio of dams that are under their licensees and step back and look at all the risks on their quote-unquote portfolio of dams. And then for us, we want to be able to weigh these risks for Oroville against those of our other dams and our other infrastructure. And that's where our colored matrix is going to be used within Department of Water Resources to help us do that. So in terms of the steps, we're right there. This level 2 is really a big part of in between 1 and 2. It's kind of where I see it fit. It's going to really help identify the measures once that report gets into the task lead's hands. How will it be used in CNA? Obviously, the PFMs for the different components will be identified, and it lets us assess them consistently across tasks. Measures to mitigate the PFMs can be identified, of course, and then the risk reduction benefits of the specific measures can be assessed consistently in terms of risk, with the idea of measures driving down the risk, either through reducing the probability of the event or reducing the consequences. Any questions?
Is the 25-page plan that outlines the specific process, roles, and responsibilities of attendees something that the ad hoc committee would have access to? You may have to redact it, I don't know.
Yeah, I would think we could provide it with minor redactions probably. And it really gets to the nuts and bolts of the workshop. A lot of it is just nuts and bolts of, okay, this person's going to do that. This is this person's role and responsibility. Here's the dates, and then the long list of resumes. So I would think it could be provided.
So we've identified a couple things now, the glossary and the 25-page report, right? That we can get.
Stars in my notebook.
Okay, got it.
Okay. All right.
This is expected to be done the end of March as a report?
Yeah, well, no, not as a report. Those were the workshop dates. I think I'd have to check our schedule, but I don't think we'd see a report till maybe August or so.
Okay.
Yeah, there'll be a lot of digestion and because there's a tremendous amount of information gathered during the workshop that needs to be organized and put in report format. So one of our plans is to, though, like we end up with tables typically at the end of these workshops and feed those tables early to task leads and to other people that are part of the process and the Part 12 board too, because they need to get an early look at some of this stuff. They'll be with us, but giving them those tables is really helpful.
Would we get a copy of the report when in that process, though? I think that's kind of what Laura's alluding to.
Yeah.
Is you're gonna have the report, it's gonna be issued to FERC. Would we have to wait till FERC gets it, or can we get it as part of that process? The ad hoc committee?
Yeah, I think around the time we'd submit it to FERC, we would probably internally go through our redaction process again and get it prepared to provide it to ad hoc or other PRA requests should they come in.
One of the concerns of the downstream citizens that I'm here to help represent was not only flood control, management, but also the effectiveness of these Part 12 inspections. The 2014, there was 3 candidates that emerged that were all ruled out. And if I could briefly read what those 3 candidates are that were never considered. Candidate F2 was that a PMF event occurred in Spillway's overtopping, head cutting occurring at the Feather River. Candidate F5 was loss of spillway channel lining resulting in erosion of rock underlining the spillway. Candidate number F6 was scouring of soil and debris during overflow in the emergency spillway, blocking the Feather River. All 3 of those were ruled out and not pursued any further.
Yeah.
The independent forensic team set out a list of recommendations under their appendix F3. I'm assuming that those have been looked at, and if not, I've got some copies where we could look at those recommendations by the forensic team and make sure that we've incorporated those into this round. Some of the things that they've talked about was the composition of the PMF team when it comes to voting, whether a candidate is pursued further or not. Could you give me an idea on what the voting is going to be as far as independent consultants versus DWR representatives?
There's been a change when we do the risk. It's no longer a vote, it's an estimation of risk. And the level 2 independent team, and this is where the independent part comes in, we asked them to develop the plan. They've developed the plan, and they've identified the subject matter experts that are going to get to estimate the risk for the PFMs. And so that's largely coming out of the IFT recommendations. And I would say that level 2 team has spent a lot of time reading the IFT, adopting and incorporating those recommendations that were provided. And so another aspect of it is that the ruling out aspect of PFMs. Everyone's going to be extremely careful about ruling out anything, and having these other categories where it's a PFM that doesn't lead to loss of life. There's going to be a grouping for that, so it doesn't go away and disappear, and we don't forget about it. It's going to be grouped in a separate bucket, so to speak, and assessed probably on the O&M matrix, where it'll be the consequence isn't necessarily just loss of life, but you got some other attributes that you need to check against. And I think Dr. Ford might get into a little bit of that. I'm not sure if your presentation has all the groupings, but that's a real concern. I agree, and the level 2 team has definitely, I think, found a way to mitigate that concern. So
looking at the guidelines for Part 12 under a FERC document, it mentions the ability for witnesses, like community members, to attend and witness the event without any, of course, input or voting. Is that still part of FERC's regulations to allow community members to observe?
I don't know where FERC stands on that. We'd have to take that back to FERC, I think. Yeah.
Okay, thank you.
Can I just make a quick comment? Maybe this is more for the board as well, but I think we have an opportunity here. I think the notion that you're going to be able to perfectly predict everything that's going to be a problem for you down the road is going to be challenging. I'm not sure that expectation is realistic. But I do think that we have an opportunity here to capture some of the assumptions, capture some of the concerns, and again, articulate the criteria that we're looking at so that the operators, the maintenance guys, the people in the field can get early senses of things that are going wrong. And then you have kind of a shortcut to go back and revisit some things that may have been excluded, not thought of, or dismissed. And I think building that into the process more explicitly would be helpful and get at some of these concerns. Yeah, like, oh, well, in 2014 they dismissed this, but was that appropriate or not? And then when you cycle back every 5 years to do your updating, you can go back and look at those criteria, look at those decisions. So it's not this, I did the analysis, I know what the answer is, but I did the analysis, I'm aware of the things that I don't know, and I'm going to kind of track and monitor those and always be on the expectation that there could be something happening that I haven't thought of. And I think as a portfolio, as a package, that will put you in a much better position than I did the analysis, I don't have to worry about it until the next 5 years when I'll go back and look at stuff. So I think that's an opportunity that we have to kind of update the process, build that in, and be more on alert throughout the operation as opposed to every 5 years.
Okay,
Thank you, David.
thank you very much.
So I'm going to start out by saying that everything that everybody said that I was going to talk about, that I don't talk about, Les Harder is going to talk about.
Just point it down at the,
Down. But this is not my presentation.
right. Do you want me to just keep advancing it? You're going through.
Okay.
That was all his. Okay, now, is that yours?
Perfect, that's me.
Okay, excellent.
Okay, so I'm David Ford, and what I had planned to talk about, which has, as you've heard, grown substantially since we started, is the evaluation criteria, and particularly the evolution of that evaluation criteria, because I know you've heard some about this, Mike, before, and I just want to kind of tell you where we are with this right now, because it has evolved. We've taken input from the board. We've heard what you've said. I've heard from my friend Steve Verrigan, hey, we got to build this thing, so let's be careful about what we've come up with because we need to be able to assess it. And so I want to just tell you where we are with that. And also, this level 2 risk analysis that's been talked about a number of times today really clearly plays into our evaluation criteria. And I want to show you how we plan to incorporate that in the evaluation criteria. But let me tell you first why we need the evaluation criteria and just remind you of that. I mean, we've heard terms today like reduce risk, or we heard optimize the operation, or enhance the reliability. And the question arises, how do we know we did that? How do we measure that? And so that's what this whole idea of evaluation criteria is all about. So I've got a few slides here to kind of illustrate some of those points. I want to tell you where we've landed with this, how we plan to implement this, and how we're going to move forward with this in the slides that I've got here. Okay, so once again, why we need it. Well, we're going to formulate measures and we're going to formulate plans. We've got to evaluate those measures and evaluate those plans. And that's what the evaluation criteria is all about. We have some requirements for doing that, though, not the least of which is we want to do this in a way that all of us can understand. We want to do it in a way that's defensible. We want to do it in a way that's repeatable. We've talked about this a number of times this morning. We want to embrace the state of the art. We want to do something now that's better than what we did in 1960 because things have evolved, and we want to capture that as much as we can. And also we've got multiple objectives that we want to consider. So we need some sort of multi-criteria decision analysis process. We want to involve that process or include that process here. So for example, we can trade off decisions or evaluations about constructability with the evaluation of flood protection and life safety. We've got to somehow incorporate all of that in our analysis. So here's how this has evolved, and I'm going to come back and talk about each one of these little pieces of this picture in just a minute. If we asked our dam safety friends, our FERC friends, at the beginning of this what we should do, they would have really focused on this diagram that's on the left. This is all about probability of failure and life safety or life loss during a failure, should there be a failure of this event. And the level 2 risk analysis really kind of is focused on that. Life safety analysis, probabilities of failure. And by the way, it's not just the probability of this probable maximum flood that John was talking about. It carries through with, okay, if we have that event, what'd you say it was, John, like 10 to the minus 4, a million-year flood or a 10,000-year flood, then we have to also include probabilities that the components of the system fail when we have that. So we get increasingly smaller probabilities. That's part of this analysis. But we realized that that doesn't really capture everything that we're interested in. So we looked at the asset management criteria. And Assemblyman Gallagher, you asked about this earlier. This asset management criteria, and Dave Sarkeesian mentioned this too, is something that's new and it's evolved. So it's a risk assessment procedure that the Division of O&M is using. Dave Duvall, when did this come to pass? About 2 or 3 years ago? I mean, it's evolved over some time, but is it safe to say it's a new procedure for asset management risk assessment?
It's a new addition to our program.
Okay, so we looked and we said, oh, maybe that's what we need to do, because it will incorporate a lot of what we're interested in terms of risk assessment for the CNA study. Sorry, I cut you off. Were you going to say something else?
No, I was going to say, it was... The asset management program, and I just was going prior to 2017, and we were starting all this, including the risk assessment prior to all that.
Okay, good, thanks. All right, so we've got life safety analysis that FERC would do and their probable failure mode assessment. Bruce mentioned earlier that the Bureau of Reclamation and Corps of Engineers do that. We've got this asset management, and then at a meeting recently, and maybe it was 1 meeting back or 2 meetings back of this ad hoc group, you also saw another set of criteria that had been introduced to this to capture things other than life safety, asset management criteria that are important to us. Things like dam safety compliance and operational flexibility and constructability. You saw that list. Well, so what we've realized is, wait, all those things are important. So we need to find a way to incorporate this whole set of different evaluation criteria in what we do for the CNA, and that's what we've done. But the primary focus has taken us back to this asset management risk criteria. So we think that that's key, part and parcel, central to the analysis that we're going to do for the CNA. And as you heard from Bruce this morning, the IRB has agreed with us that that's an appropriate way to do business here. So let me tell you a little bit about why we think that's a good thing, other than the fact that the board said it's a good thing. We think it's a good thing because, first off, it does meet the ISO standard. Now, we know that that's not all the world is about, but certainly there's some history of that standard evolving to capture what's important in the dam safety world, and we want to climb on the shoulders of those giants. It meets the CNA goal of risk-informed analysis because it does include a consideration of probability of all of these undesirable events. We can use it for screening plans and measures. It's been used elsewhere in the Department of Water Resources, and that's what David Duvall was saying. We think that that's really important because now we have a body of knowledge that's developed within the department so that we can use this method in a consistent and uniform way. It lets us compare, for example, the performance of Oroville with performance of other dams elsewhere and other components of the State Water Project. And finally, systematic and repeatable and sufficiently flexible to meet our needs. All right, so let me give you a little background just to kind of bring you up to speed about this level 2 risk analysis that several people have talked about today. What the level 2 risk analysis really looks at as a product is this diagram. This diagram has a really weird name. Bruce, what's the name of this diagram? What do we call it? Yeah, we call it an FN chart. Now, don't slip up when you say that. The F part is probability, and the N part is number of lives that might be lost given the failure of the facility that we're considering. So a typical risk analysis for dam safety purposes would estimate probabilities and life loss and create an FN diagram like this. So for for the current state of a system, or the current state of Oroville, we could do an analysis and put a dot on this diagram. And the idea is that as the CNA then improves the facility or enhances the facility and reduces the risk, that a dot on this diagram is going to shift, as David Sarkeesian was talking about earlier, to represent a more desirable state. And so we have a tool here that we can use to see how good we're doing as we propose plans and measures through the CNA for enhancement of the Oroville facility. This gives us a tool for assessing or evaluating the performance of that measure or plan that we would propose. I've got to put this diagram up here, and I think it goes to a point you were making earlier, and that is there's a lot of uncertainty about all of this. So in reality, the engineers and scientists that are doing this analysis aren't going to put just a point, because we have a lot of uncertainty about the potential performance. We have a lot of uncertainty about the hydrology of this. So it's really sort of a cluster of points here. And in the analysis that we'll do, we'll propagate that uncertainty through the math as we come up with indices we use as measures of performance of the plans and the alternatives that we're going to consider. So again, the point is that as we look at the CNA alternatives, we'll do this analysis, we can make this plot for each and every one of those, and we can see how the plans and measures perform. So that's our evaluation criteria if we just focused on dam safety. You skip that slide. I'm going to go right to this one, because here's the matrix, or here's a representation of what the asset management risk analysis does within O&M. In asset management risk analysis, rather than pretending that we can sharpen our pencil, Ron, this goes to what you and I were talking about earlier. Back in the days that I was a young man, I took a drafting course, and we did it with a really sharp pencil. Well, we could pretend we could sharpen our pencil enough here to know just exactly quantitatively how everything performs, but we don't. And so as a consequence of that uncertainty about performance, the asset management criteria says, well, let's put things in categories. Categories of outcomes, categories of probabilities or likelihood, and let's assess, evaluate actions that we might take in terms of performance in those broad categories. We shift from one category to another. The asset management process says we'll multiply the consequence category number by the likelihood category number, and we come up with an index that represents the performance of an action that we might take. And a smaller index means better. So you can imagine then, as we come up with these different spillway alternatives, in task one, a different spillway alternative would shift either the consequence or the probability and move us to a different box in this asset management criteria. And Joel, that lets us compare different alternatives that the task one spillway team would come up with. And the good thing about that is that there's no mystery about how we do that, because the asset management team in the division of O&M has developed documentation to explain to us how we make a determination of either the shift in consequence or the shift in probability. Asset management risk strategy has identified a broad set of categories of different consequences or outcomes of performance with different alternative measures. We're going to adopt that. We're going to expand that to include the other criteria that we were talking about earlier. So here, broadly speaking, it has public safety, but we see here an opportunity to merge in this level 2 risk assessment. So rather than using directly the asset management idea about public safety, we can bring in that FN diagram and incorporate the results of that. So we've got here a little bit of a mix of very sharp pencil ideas, Ron, with life loss estimates and probability estimates, and some broader pencil ideas. For example, measures of other benefits that might arise from the alternatives that we might put into place. Okay, so this illustrates sort of broadly a chart, a flow chart of how we will apply this asset management merged with the life safety analysis from the level 2 analysis to evaluate alternatives for the CNA. We'll select a condition of the system, so we're going to start with what the system is right now. And by the way, that would include probabilities of failure or poor performance of every piece of that system. So not just the chute spillway, but also the headworks, the other facilities, the Hyatt power plant, all of those facilities will be included in this, and probabilities of failure will be estimated. In the CNA, we would go through the process then to find a score that represents the current performance of the system. Then we'll take the alternatives one at a time and go through that process again and compute a score, a performance score that represents how each of those alternatives would perform if it's implemented. And then we can compare those alternatives. And so back to my original point, we've talked about reducing risk or optimizing operation. How do we know we did it? Well, that score is going to tell us how we did it. This simple chart here is to remind me to tell you that it's a multi-criteria decision analysis, though. It's not just life loss. It's not just state water project delivery. It's not just constructability. We have to somehow incorporate and integrate all of those different criteria. And so we'll use a multi-criteria decision analysis tool. Perhaps it's some sort of weighting. That particular detail hasn't been worked out yet, but it will be a tool that lets us consider the relative importance of all these different criteria that we establish for looking at and comparing the CNA plans. And I think that's kind of the point here. The last point, though, that's really back to David Sarkeesian's point, and that is this level 2 risk assessment that's starting next week and going on when, Sergio, like forever, I think, right? A month's worth of 2 workshops or 4 workshops to consider all of this. All of those results will be rolled into our combined or integrated evaluation criteria. And this diagram here is simply an illustration of how we now have a plan to take the FN diagram and to merge that FN diagram with the matrix that's developed from the asset management operation and maintenance risk strategy. So we're left with something that looks like this. So what we'll do then is for the existing condition, go through these 100 failure modes or so that have been identified. We'll find where we are on this diagram. Then we'll take the alternatives that are proposed as a part of the CNA, go through that process again, and see where we've shifted on this diagram so that we can compare alternatives. All right, so I know there's about 50 other things that I got tagged with talking about that I forgot to talk about, and I'm sure you're going to remind me what those are. So, questions?
As part of your analysis, and we've talked about this before, assumptions are kind of a critical component to structuring this whole thing. Will there be an inventory of assumptions that go into all the analytic steps that would be available for review? And I'm thinking ahead to the August 2019 meeting for us. Was part realistic for some sort of report to be done?
So there's a couple questions there. So let me kind of parse them. In regards to the inventory of assumptions, I think that's an outcome of the level 2 risk assessment. So the level 2 risk assessment will take each failure mode in turn and follow it all the way through the whole process. So what was the loading? What was the hydrologic loading? What was the seismic loading? What was the probability of initiation of a failure at that point? What's the probability of progression of a failure? And so that whole set of assumptions will be tabulated as a consequence of that level 2 risk assessment.
But even to the point of the probability or the likelihood of failure is 10 to the minus 3. What's the basis for that? There's an assumption that goes into that element. Is that level of detail going to be included in the documentation for the analysis?
So broadly speaking, the answer to your question is yes. It goes back a little bit to what David Sarkeesian was saying about the process for the level 2 risk assessment. And so he mentioned, I think you used the word estimators or evaluators. I forgot what words you used, David. But in this group of 60 people or so that will participate in these workshops, in some cases, no one knows with certainty what that probability is. And so the estimators will make an estimate of the probability. Each of those estimates will be tabulated. And I'm not sure to what extent, but each of those estimators will provide their reasoning for what probability they estimated. And so that will be carried forward into the report. So I think the answer to your question is yes. Maybe not at the level of details so that every one of the 60 voters will have a page of description, but certainly there'll be some explanation of why the number that was used was used.
Yeah, maybe more of a request as opposed to a question. Another question is, and I'm not super familiar with the Part 12D analyses, but how do you deal with interdependencies where you have a primary effect, but that then has a ripple effect, a secondary and a tertiary? Are you focusing just on primary stuff and then not really capturing the secondary or tertiary? How do you deal with the interdependency concept in the analysis?
So I'll give an answer and then maybe no, the best thing I can do is Les is going to answer that question. No, but let me give an answer to that. So the simple answer, I think, is that in the Part 12 process, for each of these failure modes, the mechanism that leads to the failure is elaborated on in the documentation. And so we would say, well, for this failure mode, we have an occurrence of the probable maximum flood, and we have a failure of the gate structure, and we have this and that, and so all of those secondary effects and sort of sub-events that would lead to the failure will be documented in that, and probabilities assigned to each of those.
Okay, no, that's great.
So I think that's just part of the typical Part 12D process. So
you're capturing the interdependencies in the framing of the scenario.
That's right.
And so if it's not in the scenario, it's not accounted for.
Well, I think that's a fair statement, yeah.
Okay. And so here's maybe a challenge for the team as they move through the process. The research that we've done on catastrophic situations that have unfolded over the years is that maybe 25% of the quote-unquote risk is quantifiable and can be analyzed. You still have a vulnerability of maybe 70%, the far majority that never makes it into a scenario, never makes it into an analysis. How do you account for that? I think it's referred to as residual risk in some frameworks, but I think that's misleading because residual implies a remainder. It's just a little bit. It's not a big portion. So I guess the challenge to you guys as you move through this process, can you disprove that hypothesis that really the far majority of your vulnerability is in the stuff that you haven't analyzed, but the stuff that's out there and hasn't been quite characterized yet?
So I guess that's kind of what Secretary Rumsfeld referred to as the uncertain uncertainties. Or
well, let me put some certainty to it. If you look at the new Transbay Terminal in San Francisco, you may be familiar that they've had some issues with beams crossing over a street. And they just came out with a report that said it was this trifecta of things that happened at this one location, and who would have known? So if you look to a lot of these catastrophic incidents, it's the stuff that you didn't think about that you have to be on guard for and aware of. So it's great to do the Part 12D stuff. It's great to do the quantitative stuff. But my question back to y'all is what about the qualitative stuff, the things that you know are out there but you can't quite put numbers to? How can we also address those elements?
So I'll answer and then.
In
I probably
August, you
should-
can answer me in August if you want. You don't have to answer me now, but that's a challenge to the group. There's the easy stuff, right? That's the stuff that ends up in your chart. But how do we confront and deal with the not easy stuff?
And I could give you just a quick answer, though, and delay the more formal elaboration until later. But I think part of what the department hopes to achieve by having this large group of people in the room is to capture some of that. So these are not people who are all of the same discipline. They're not all DWR employees. There are a lot of independent consultants in this room. And I think we hope that having that many people think about this is going to increase the likelihood that we'll identify some of those. Now, there's no guarantee, of course, but I think that's part of the reasoning, David, got enough names here, but David and David, for broadening this to have 60 some odd people participate in this level 2 risk analysis is you want people who have evil minds to think of these unfortunate circumstances that might arise.
Yeah, I think the devil's advocate position is very important. But another thing you may want to consider is tracking and logging near misses or things that kind of deviate outside of what you expected, and then having that catalog of assumptions to go and do a cross-check. I think that's a real thing that you can do so that you're mindful of the context. This is what we thought, calibrated against what's actually unfolding out there.
No, good point. David, do you have anything you want to?
So, Rune, you're crossing over into how you're managing the asset as opposed to doing that risk analysis.
But they're linked. They're absolutely linked because they're characterizing the state of the system, which if they have no idea what the state of the system, what is the utility of the analysis?
Absolutely agree. But what I'm saying is that is the legwork of pulling in documentation of what the analysis to bring into that. And so part of how you set up your asset management program is that what are all your metrics, what are all your service levels, how do you measure, how do you put in process plans and procedures, what are the checks and balances, and that all then feeds into each comprehensive assessment each year, each of the 5 years.
So we could test that, and I guess one concept that I'd put on the table for consideration is go through the Part 12D process, and then maybe you could cherry pick 5 to 10 people who are intimately familiar with the operations and maintenance of the various structures, form a red hat team, if you will, to see if you can't ferret out some scenario or some possibility that the SMEs didn't think of as they went through. I think that's another check that you can do to help convince yourself that you're capturing that larger portfolio. I guess what I'm trying to say here is there's the routine process, and can we think of additional ways to enhance or embolden that process so that we're convincing ourselves we're getting as much of the vulnerability as possible?
And this is sort of the work that you guys do at the Center for Catastrophic Risk Management, right?
Yeah.
Because I think what we're getting at here is that there is a process and there's metrics and there's measures that we're kind of used to. This is what I'm hearing as a layman, as a non-engineer, okay? What I'm hearing from some of this discussion is that we have the things that we know and we have experts and we have different perspectives, and we can all sit down and we can say, hey, this is the way we measure and figure those things out and what's acceptable levels of risk. But even with that, and even with some very smart people in the room all looking in that, we're kind of in the box that we know, right? And that maybe there are these other things that just, they, for whatever reason, don't get captured by our normal process. Is that right? And so I think what Rune's saying, hey, because a lot of times when you have these catastrophic events, they're not necessarily the things that you ever would have thought of, right? Otherwise, they probably wouldn't have happened in the first place, maybe? Is that a good way to characterize it?
Can I just?
Right? Yeah, maybe, go ahead.
Well, I think, the FERC, because of the forensic report, right, FERC told us, give us a plan for how you're gonna address all these recommendations, and we're about to send them our letter. We sent them a letter back in the summer, and they said, we want more detail, and we're about to provide more detail. I think you're bringing up good things that hopefully not hopefully, we are including in the other parts of our program enhancements, because as part of that, there was an audit team that we also brought in more external experts through FERC. They came in and audited our program, and they saw how we were incorporating it into asset management, which includes the whole life cycle. This is like one square. This is the design side. Then it goes into the maintenance side, which is asset management. They gave us recommendations there on how we're going to better inspect, how we're going to be better evaluate, how asset management is going to take all those areas and also incorporate them back into the life cycle. So I think we're doing that. Now, are we where the industry needs to be? No. I think everybody knows the industry needs to keep improving, but this was our first attempt to address the forensic report of not just design, but how are you going to operate and how are you going to inspect and how are you going to maintain. They're in all those components. It is a multi-year program. We can't do it all in 1 year, but we're going to step through trying to improve, and I think it's what you're bringing up the O&M side of it, so that all the data that's being inspected from the inspections, the visuals are going into our SAP system where we're catching all the data so that the subject matter experts within the department have all the data available to catch things that are happening that we don't either understand or are leading to something. So I think we are trying to put all those pieces together.
Sure.
Not everything is in the CNA, but
Well,
but
and that's
it's
where
in
I'm
the whole-
suggesting, and I think the board would be suggesting is, would it help to incorporate some of these things that Rune's talking about into your overall your risk evaluation criteria? I think it's something you really should consider, and I think they could help you in saying, hey, have you considered these things, or are there some ways that you can test your underlying assumptions about? I don't want to speak for you, but I just think that that's kind of where you're going with, I think, your suggestion.
We're early in the process. We know that the process as of 2017 was not as comprehensive as it could be. We've identified some enhancements or some betterments to the process, and it's not too late to incorporate those moving forward, which would then put you in kind of the state of the practice. I'm doing what FERC told me to do, to state of the art, saying not only am I doing what FERC told me to do, I'm doing these other 14 things. I don't know if all 14 are going to be useful. I'm going to give them a shot because I'm going to advance the state of the practice. That's an opportunity that I have in front of you right now, as opposed to, well, this is all I can manage, this is all I can handle, I'm going to do what FERC told me to do, and I'll cycle back to this later in 3 years or whatever it is. It seems like a missed opportunity.
So I'd like to offer another perspective there too. I think be very careful that the level 2 analysis that FERC has asked DWR to do goes far beyond anything that has been done in the sense of traditional engineering analysis of dams. This whole risk assessment process is really set up to bring out exactly what Rune is talking about, that it is not limited to those things that we can calculate, that we have models for. Those are all things that if we have that information, it factors into the estimates of risk. But the framework that has been proposed is also set up to allow people to bring in those, what would I call it, notional factors that are kind of the non-quantitative things. And what you're going to find is that will all get discussed in the process. And to the point of documentation, every estimate for every probability in the event trees will have a listing of what are the factors that make it more likely and what are the factors that make it less likely, and identify that these were the primary factors that the estimating group based their estimate on. So all of that is going to be captured in the documentation. And I can only say that because I lived it for 20 years in the Bureau of Reclamation. And most of the people that you have on the team have come up helping us develop the Bureau of Reclamation program.
So Bruce, is it your position that the current FERC 12D process is complete? That it captures everything that you should be looking for?
So the current FERC 12D process is not the level 2 risk assessment.
Okay, so
So
is it your recommendation then that DWR should do the Part 12D process? And again, I'm not an expert on what all the connotations are, but
Yeah.
they're doing a level 2 risk analysis. So if your notion is that the 12D process is complete and exhaustive, isn't that what we should be doing?
No. So my notion is that the level 2 risk analysis is a far more complete process, and its results will inform both the FERC Part 12D and the CNA.
Okay, so the level 2 risk analysis is going to cast a net over everything you need to be concerned about.
Correct.
Is your
And I
position.
think that was in David's presentation, that when you look at the clouds there, that the level 2 analysis encompassed everything.
So would you also agree then, if we put together a little red hat team at the end of this process, that red hat team would be unable to find anything that the level 2 risk analysis didn't identify?
I think that's an unreasonable assumption. We've tried it before in reclamation as we were trying to formulate this process. We actually had a dam that came back and said that there was a 1 chance in 10 of it failing in any given year. But the dam had been there for 90 years. And so we're like, that doesn't make any sense. So we created a second team. They came back with exactly the same result. Ultimately, we found out when we were putting in some instrumentation, the dam was failing. It just hadn't reached that point yet.
But I think that's the notion that I'm getting at is in your example, it would have just been a one-time thing. Here's the answer, I'm going to move on. But you brought in a second team to double check, and you did instrumentation. And I think that's the notion that I think would be helpful in this process here is don't just stop at the end of the analysis, but keep going, keep exploring those assumptions and build that into your process.
So I think that's part of the review of what's done.
FERC conducted a after-incident panel, and that was one of their recommendations, is that you bring in another team to look at the final results and findings and scrutinize it through another set of eyes.
Yeah.
And I don't know if they plan on doing that following Oroville's Part 12, but I think it was a good recommendation that panel made.
So the practice that we would use in reclamation was if we were sitting on the fence as to whether or not to take an action, was when we would come back and do more to try to confirm one way or the other. If you come out that in the results, the risks say clearly your orders of magnitude into the area of where you need to take an action, getting another team to look at it isn't going to change the conclusion. Likewise, if you get a result that says we're an order of magnitude below a risk that would cause us to take action, not likely that you're going to find something radically different in that.
So let me just sum this up a little bit by saying, like, there's going to be this level 2 risk analysis, which I think is good, and it is, like you said, it's much more comprehensive than anything that's been done before. But since this is an area that Ruin Center really focuses in on, like, hey, what are we maybe not getting? Maybe trying to incorporate some of their things, you know, maybe even having Ruin, because I think he's a pretty good resource, you know, as part of the teams that are looking at different aspects of this level 2 risk analysis, because that is going to be key to informing, right? Like you said, that really is going to tell us, maybe it's going to be very informative to our other processes, including this one, right? And Part 12D inspections in the future, right? When I look at this specific incidents, right? Again, as a layman, but looking back on that forensic report, it's like okay, we did Part 12D inspections, and there were things that were brought up like, well, yeah, we were repairing these cracks every 10 years on the spillway. Why wasn't that ever indicative of like, and they follow the herringbone pattern of where the drains are? Why wasn't that ever indicative of like, okay, well, maybe there's something more fundamentally wrong here, right? But it was instead what happened, according to the report, was, hey, this was normalized. Like, oh no, this is what we do every 10 years, and there's really nothing, you know. And there was also the, hey, well, what's going on with the geology? Oh, it's really sound, competent rock, which was really just a cut and paste from one portion of the geology report. Nobody ever said, well, hey, okay, what's your basis for saying that? How do you know that, right? And I think that's something that probably should have been done, right? But it just wasn't, right? Now, there could be things that are even bigger than that, right? That we're just not even thinking of is what I think the concern is, and how is that caught by sort of our better processes to make sure that we're taking into account the potential risks that are out there?
I would just like to add, I view the whole process as it's a living process. We're going to get a huge update through this level 2 that's going to be conducted the next 3 months. And those PFMs and those risks are going to be tracked, and we're going to partner with asset management to develop a process to do that consistently. And and then in the next 5 years, all those are going to be brought back to the table and looked at again, reassessed, and new ones will be discovered, I think, along the way. The other component is we've got the operators in our workshop, so their concerns can be brought to the table. And then we also bring those back to the other folks here in the field division that didn't necessarily get to sit in the workshop and brief them on what failure modes did we discover. And as part of training, but it's also going to provide a feedback loop so that the boots on the ground, nuances of the facilities are getting back to the engineers that are sitting in these workshops. So I think it's a living process, and every cycle we do it, we're going to have a bigger and bigger portfolio of things we're watching for.
John, we have
Okay.
30 minutes, and I have to get him out of here
Better get-
right at 11, and I know Laura, so in
Right.
the interest of time, do we have enough to?
Yeah,
get
so let's do this. Let's, maybe, Ron, if we could just do the condensed version of looking at the table of contents. Let's spend the bulk of the time with Les's presentation, and then we can shrink down, or even, if you guys are comfortable with it, we can cut out because we were just gonna do a real quick summary of, the
Bill,
1,
I
2,
think
and
Les's
6.
presentation should be priority, so.
That's my thought, so I think.
I think,
that-
yeah, just starting on we're going to get into the task 4, right?
We'll just focus on that one.
And then task 1, 2, and 6, right?
Rhonda, give us real quick, maybe the 5-minute version, and then we can.
All right, well, good morning, everyone. First of all, I just wanted to introduce myself. I haven't had the opportunity to talk to you yet. I am Rhonda Robbins. I am a member of the integration team. The other members, of course, it's headed up by Sergio, Steve Varrigan, David Ford, and Les Harder. And one of the things that we're working on is the final report. So I think you'll remember that the IRB made the recommendation to, and I think the phrase was, to start at the beginning with the end in mind. And so that prompted us to get our outline together. I think you have this outline in your packet today, so we're going to go through it pretty quickly. So one of the very most important parts of our report is going to be the executive summary. Chances are most people will only read the executive summary, so it has to be comprehensive and written in such a way that it can be a standalone document. The next chapter, we're going to jump right into the meat of the document. It's the introduction and the project motivation. So this is what I think of as the Google Maps, where you zoom in. What are we talking about? Where are we? The physical components of the facilities, and then we get into the why of the CNA. Why are we doing this? And you can see the details there. The next chapter, chapter 3, is the goal, constraints, assumptions, and opportunities. So no surprise, there are 6 individual tasks, and they are also coming up with these very same things. This chapter will roll up from the individual tasks to the project level, and will identify those things that cut across the whole project. Chapter 4 is organization, approach, scope, and deliverables. So this is where we, first of all, we introduce the concept that this is a water resources planning study, and that comprises 6 steps that have been somewhat modified for the CNA. And then we'll go into describing the 6 technical tasks in more detail. One of the important things here is that we'll describe what we call the baseline condition. That's the without project condition. That's going to be the starting point for evaluating the risk reduction of each of the plans that we come up with. Okay. Chapter 5 is going to summarize the upcoming level 2 risk analysis. You've heard a lot about that already this morning. Chapter 6 is going to basically be David Ford's and David Sarkeesian's evaluation presentation. So what were the evaluation criteria that we used, and why were they appropriate for the CNA? Chapter 7 is going to be a summary of everything that happened in the individual task levels. So each of the tasks, of course, will be writing their own report, and then this chapter will summarize all of those individual reports. Chapter 8 goes into formulation and evaluation of the alternative plans. So we use the term formulation to mean the individual measures from each of the tasks get rolled up together in various permutations. That's formulation, and then they will get evaluated according to the criteria that we identify. Chapter 9 is going to zero in on the preferred portfolio of plans. So you remember the scope of the CNA is not one specific plan to be implemented. It's a portfolio of equally preferred plans. So this is going to identify how we got there and what those plans are. And then Chapter 10 is a recommendations chapter. So here we're going to have that portfolio of plans. We're going to hand them over to DWR Executive Management and their various informers to figure out how to get from that portfolio to that one single plan. That's going to tell them our recommendations for how to do that. If within the CNA we come up with urgent concerns, we'll identify those there. And then if we come up with early implementation plans, that will also be identified there. It will have the usual stuff at the back of the book, right? The references, the acronyms, and then we anticipate a number of appendices, including what we've talked about today, the glossary, and the individual final reports from each of the tasks will be there too. The level 2 risk analysis will have its own report, and then we anticipate that the CNA will also generate its own risk reduction report. So that will be included there too. All right, that's the real quick version. Happy to entertain any questions you may have.
Well, thank you.
All right.
Looks well done.
Thank you.
Thank you.
Say, Les, why don't you plan on, say you'll have Les plan on taking us home to 11 o'clock. Just use that time there, and then if you guys have any specific questions, we got the slides in there on the other 3. Those are going to be pretty brief presentations to you guys anyways, and then let us know if you have any questions about those, and we can follow up there.
Good morning. So for those of you who don't know me, I'm Les Harder, former DWR employee, now a consultant back to DWR. I'm going to talk about update to Task 4, which has to do with looking at low-level outlets, both the existing and possibly new low-level outlets. I want to follow this general outline, probably try and do it quicker than I thought I was going to do it, but talk about the overall needs statement for Task 4 and objectives, talking about objectives and constraints, give you some examples of some evaluations we're going to have to be doing, and then some other pertinent updates related to
what a reservoir drawdown looks like, show you some of our calculations, look at seismic shaking for the site and what would happen inside of Hyatt, and potential reservoir drawdown limitations and benefits. So you've seen a version of this slide already today. The CNA process is a planning project. It's going to follow 6 steps of a typical planning study. We're in step or phase 1, which is basically trying to identify needs, constraints, and measures. So needs, we talked about terminology. What are needs? Well, these are things that arise after you look at your baseline condition and see if things are appropriate, you have appropriate risk management, everything is meeting your criteria and project needs. And when we say baseline, that's not 50 years ago, as Rhonda said, that's what it is today, considering the age of the project and the reliability of the project. Our objectives are things that are measurable and actionable targets to be met with measures, and then alternative plans. So the way we've termed things is we have different tasks for different facilities of the project. The emergency spillway is associated with task 1. Task 3 is associated with the headworks of the FCO. Task 4 is low-level outlets. Task 5 is embankment. Each of those tasks will have measures that might improve things, improve the physical reliability of those facilities. And then they'll be combined into plans, which are combinations of measures from the different features. Constraints are things that limit or restrict action taken to address the needs or opportunities. So earlier, Bruce talked about some of the fact that we've identified constraints already. Some of them are hard constraints that we can't violate, and some of them are soft constraints that might be able to be modified or adjusted with time. So first start out with the review. For low-level outlet, why do we need a low-level outlet for the most part? Well, the primary thing is risk reduction, is the ability to evacuate the reservoir quickly in case something bad has happened to some other feature of the project. So what would be an example of a bad thing? Well, if you had a big earthquake here, and we don't think this will happen, but if you did have a big earthquake and you had the dam slump, you'd want to take the reservoir off of it as soon as you could. And you want to take the reservoir off quickly. So we have a facility that can take off the upper part of the reservoir pretty quickly. Our Division of Safety Dams has criteria for rapid or emergency reservoir drawdown. They have 2 sets of criteria. One is they would like you to be able to take the upper 10% of the reservoir height, take it off within 7 days. So in this case, the reservoir is roughly 600 feet deep, so its height is 600 feet, 10% of that is 60. You want to be able to take that off in just 7 days. Well, we have a facility called the FCO Spillway that you're all familiar with, gated spillway. It can easily do that. Meets that first criteria quite well. It can take that 60 feet off in 2 or 3 days if everything's working. So Rune, I think you were talking about, well, what about secondary things that might happen? Well, one secondary thing might happen if you had a big earthquake that caused a slump in the dam. Gee, could that jam the gates so you can't open them? And not open them for weeks, maybe? So that's something we're going to have to look at. Now, the emergency spillway can operate, the control spillway here, the FCO, it can take off the upper 87 feet because its sill elevation is 813, so 900 down to 813, the upper 87 feet. Below that, we rely on the Hyatt power plant for releases. That's the buried underground power plant. And I think most of you have been there, or at least seen that. So it's in a cavern here, has a sloping intake that leads tunnels and penstocks to the power plant, and then they discharge water from the plant in the old diversion tunnels. These are the 2 diversion tunnels they built for the construction of the dam. They plug them here, and they discharge there. So you've all driven and seen these 2 sloping intakes. Each of them takes water down to the underground power plant. It's actually, the plumbing is more complicated because each of them actually divide into 3 because it's a total of 6 units. They go through the plant and the plant discharges in the old tunnels. One of the things about this is there's a lip right here at elevation 628, no water can get in. You know, so if the reservoir gets below that, the plant can't release. And actually the units stop working when the reservoir gets down to about 680 to 650. So we can take down the upper half of the reservoir with the power plant, but we can't take down the bottom half. It stays there, it's a stagnant pool. So we do have a third outlet called the river valve outlet system. It's in one of these plugs in the diversion tunnel. There's two pipes. These are 6-foot diameter pipes. They can release water when Hyatt is not able to release, but they can only release a little bit of water, only 2,000 to 4,000 CFS. So that keeps the river full in case during drought, but it can't pull down the reservoir because that 2,000 to 4,000 is such a small capacity. Right, so task 4 needs statement, some of our objectives and some of our constraints. So we've modified this a bit since IRB meeting 3, which was about 3.5 weeks ago. Tried to clear up what are objectives related to redundancy versus related objectives for new additional facilities. So our overall task need statement right now is, are additional outlet facilities needed to provide redundancy or additional reservoir drawdown capacity at Oroville? So our first objective is determine whether new outlet facilities should be added to enhance redundancy for the FCO gates for the upper reservoir. Like I said, the existing system more than meets safety dams criteria of its first criteria of bringing down the upper 10%, but is it always going to be there? Will that capacity be reliable, or do we need to put something else in to provide redundancy? The next objective is, do we need to put something in for redundancy for Hyatt? So Hyatt can pull down the upper half of the reservoir, but you know, there's reliability issues with Hyatt too. Our third objective is, do we need to provide additional capacity for emergency reservoir drawdown of the lower reservoir beyond? This is not redundant, this would be a new capacity. For instance, be able to take all the reservoir out. So safety dam's second criterion is they want to see, for new dams, the ability to evacuate the entire reservoir in 6 months. Well, they came up with that criteria in the 80s after most of the big dams in California were built. So hardly any big dam in California meets that right now, including Oroville. But do we need something more than just redundancy? So these first 3 objectives are related to emergency reservoir drawdown. This last objective is, do we want to provide additional outlet capacity for operational needs? So when they're in droughts, when the reservoir gets low, and Hyatt becomes challenged in releasing water, they rely on the river valve outlet system, which is not a really big outlet. And so operationally, there's a desire to have more capacity at the lower reservoirs. And so we're going to be looking, that would be an additional benefit as opposed to a risk reduction measure. Some of our constraints, we talked about some of them earlier. There are physical limits of the existing facilities, even if they work perfectly. They can only do so much, they only draw down so much of the reservoir at any point in time. Then there's another constraint is the reliability. How reliable are they going to work? We talked about risk, tolerable risk. That's a constraint that you know, we're going to be trying to follow as we look at managing the facilities. There are regulatory requirements, you know, both at the federal and state level. And there's additional physical constraints. You know, we have a river channel that only has a certain amount of capacity, can only carry so much water. We have the constraints of the geology. It was already mentioned, I think one of the recommendations of the IRB is look more at the geology as well. And there's physical limitations. I mean, the left abutment of Oroville is already pretty crowded. It's got basically 4 tunnels and a powerhouse in it already. So it's going to be hard to fit another tunnel on that side of the channel.
Is money a constraint?
I think cost is, I mean, all resources are a constraint. So people resources, money resources, that's always going to be a constraint. And it will be consideration in looking at everything. So in going forward with task 4, we have about 30 or 40 different evaluations we need to do. And I wanted to just give you an example of some of them. So, for instance, for this objective of do we need to provide additional capacity for the emergency reservoir drawdown of the lower reservoir? What do we not know right now? Well, one of the things we don't know is that what risks are we trying to mitigate? You know? How fast do we have to draw down this reservoir? How much do we need to draw down the reservoir? Why? What are we trying to fix or prevent? Are we worried about something on the embankment? Are we worried something about the FCO? Are we worried about something about one of the tunnels? What are we worried about? What are we trying to do here? I mean, our main benefit is risk reduction. So let's quantify the benefit. We don't know that. What are we going to do to try and find that out? Well, we're going to work from task 4 with our other tasks and with the level 2 risk analysis to basically try and understand what are our existing risks and what are the potential failure modes and what's the benefit of being able to draw down. So for instance, if you're worried about cracking of the crest, well, most cracks don't go down more than 40 feet. So after you pull the reservoir off 40 feet, maybe you've eliminated most of the cracks, that potential failure mode. You really don't need to go down another 600 feet. With regard to regulatory requirements, right now there are no requirements in safety dams or FERC for providing redundancy for outlet facilities. But that doesn't mean that they'll stay. So what would be, one of the things we need to know is what are the requirements going to be with time? And I think Bruce touched on this, and one of the recommendations by the IRB is don't concentrate on necessarily past guidance, but work on good engineering solutions. And that's what we're going to do, is we're going to work on good engineering solutions, look at how we're going to manage the risk, and see, what risk benefits are we going to get. And I think, when we work with the two agencies, they're going to follow what we are going to recommend, because it will make sense from an engineering perspective. And then finally, again, one of the constraints is we have to work with the facilities we have. One of the questions is, we have 2 big diversion tunnels already. They're 35 feet in diameter. Can we make use of one of them as part of a new low-level outlet? We don't know. That was a recommendation from a past workshop, is to consider using one of them. But those tunnels are 55 years old. We don't know the conditions of some of them. You would have to make extensive modifications to Hyatt if you were going to actually use one of them. So we're going to explore that, and the way we're going to explore that is we'll develop some preliminary, alternatives for using parts of the tunnels, see if there's any fatal flaws with them, and then if there aren't any fatal flaws, we'll carry them forward for further consideration. If there are fatal flaws, we'll drop them and look at other measures. So I did want to talk a little bit about reservoir drawdown, what we can do now. So this dashed line is the California Division of Safety Dams guidance for new dams. We call for the upper 10% of the height in 7 days and the rest of the volume in 6 months. So this blue line represents what we could do now if we used everything we currently have and everything worked. So that means all 8 gates of the FCO are fully open, they're operational, fully open, out of the water. That means all 6 turbines at Hyatt are working at their full capacity. That means the river valve outlet's open. And there's also this assumption of 5,000 CFS inflow. In safety dams criteria, they say you should assume no inflow. But there's always inflow. So if everything works, we more than meet the criteria for the upper half of the reservoir, and then we don't touch the criteria for the lower half. That's if everything works. Now we talked about inflow a little bit. So in that example, we picked 5,000 because that's probably about the year-round average inflow. So this is a histogram of 10 seasons from 2003 to 2012. And the heavy red line is the average for those 10 years. So if you look at this, then 5,000, which is this level, this line, that's probably pretty good as an average overall. You know, during the summer and the fall, it gets down to about 2,000 or 3,000. Parts of the winter average around 10,000. So 5,000 is probably pretty good. But you can see in certain seasons, it's not only above 5, above 10, but there's certain parts that are above 20,000. So we'd have to consider that if we're really going to be realistic. Go beyond what the requirements are of safety dams. So we're going to have to consider the likelihood of having more than 5,000 or more than 10,000 when we actually want to do a reservoir drawdown. This is a plot is pretending that the FCO, the gated spillway, is not working. What could we do with the just Hyatt? So this is assuming just Hyatt, no gated spillway, no river valve outlet. The dashed line again is safety dams criteria. This is the upper 10% of the height in 7 days, and then this is going toward total emptying it. Well, if all 8, oh, I'm sorry, this is the FCO. This is, I made a mistake. This is the gated spillway. So this is all 8 gates here. This is if we limit it to 150,000. This is 2 gates. Says basically we need 4 gates to meet the criteria. This is the one I started talking about, which is about Hyatt. If the FCO is not working, and we have all 6 turbines, we can come down, approach the criteria. But if we only have 3 turbines, we're not really working too well. And actually, if there's no turbines working, if only 1 turbine is working, the inflow overcomes that, and you get a spill over the emergency spillway. Some of the things we want to look at is, all right, if we want to put a new tunnel in, where should the intake be? What elevation? Do we want to evacuate all of it, all the way down? That's down to about elevation 340. Well, Bruce mentioned that, you know, if you do a hot tap, and you'd have to do a hot tap if you go that deep, there's construction risks. I mean, if you make a bad mistake there and you lose the reservoir, that's catastrophic failure.
Just build a train and sell it for gravel.
So the deeper you make the inlet, the more construction risks you have. So what benefits do we get for making it deeper? So pulling it down deeper doesn't always give us the most benefits. So this is an example. Here's the cross-section of the dam. This pink zone right here is the core, the main dam core. This pink zone is the core of the cofferdam that they built first. If you were worried about the core cracking and having internal erosion, you'd want to take the water off of that. Well, if you pull the reservoir down, after you get past the height of the cofferdam, you're trapping water in the gravel. And the pore water pressure that the core feels stays at this elevation. You could completely empty this, but because of the way the water would be trapped here, you're still loading the core up, and you not have unloaded that. So taking it lower for this potential failure mode doesn't help you. So that's a consideration we have to look at. Another consideration for the other benefit of better or improved operations is the level we put the low-level outlet is how, you know, the lower it is, the more benefits we get from an operation. Now, if we put it at the intake at 700, these percentages represent the likelihood that the reservoir could go lower than that elevation. So in this column, this is 700 feet. And the reason why we picked 700 feet to look at is that we could do that in the dry, because we can evacuate the reservoir down to 700. That's where it's under 700 today. And we could actually do a lake tap without actually having a lake there. We can actually make the connection during the summer. Well, some of the benefits are is that, well, depending on what month it is, it's 10 to 30% of
of the time, the water reservoir will go lower, which means that you're not fully capturing the potential benefits that the new low-level outlet would give you. Well, what if we made it a little bit lower, let's say 680? Well, that's better. You're now in the 5 to 10% range. But 680 is about the limit of how far we could go in the dry to make the connection. If we went down to 550, and that's the top of the cofferdam core, we're getting down to, well, it's not too much benefit from operation at that point because the reservoir hardly ever will unlikely get that low ever, and only be a few % chance that it would ever actually get below that. So from an operations point of view, 700 provides some benefits. 550, you get almost all your benefit, but after 550, lowering it doesn't help you. And so that's what we're going to have to weigh in these alternatives, is construction risk and cost versus what benefits are we getting from both risk reduction and operational benefits. I did want to talk a little bit about seismic shaking. At Hyatt, we asked Lettuce Consultants International, a seismology, engineering, geology firm, to give us an estimate of what would the shaking be like inside of Hyatt, given a certain shaking outside. So most of you will remember we had an earthquake here, magnitude 6 in 1975, August 1st. It was about 1 o'clock. I was in Davis at the time. I felt it. It produced a peak acceleration of about 0.14 g. This is percentage of gravity, 0.14. And if you look on the USGS charts, 0.14 would be about a 500-year earthquake. So that's what the dam has, experienced. When we look at analyzing it for potential future earthquakes, we take the maximum magnitude that's thought to be credible on the system, and that's on the Cleveland Hill Fault, which is about a mile east of the dam. It could produce a magnitude 6.6. So the median earthquake, or medium acceleration from a magnitude 6.6 on the Cleveland Hill would give us about 0.35 G, and that's about a 5,000-year earthquake. But we don't take the median when we average. Because of conservatism and uncertainty, we actually take the median plus one standard deviation, or the 84th percentile. And so the 84th percentile is about 0.6 G. That's a 25,000-year earthquake. So that's what the critical facilities of the Oroville complex are being analyzed for, or have been analyzed for, like the dam. But what kind of shaking would you expect inside a cavern deep in the mountain, where Hyatt is? So that was the question we asked LCI, and they said you should be expecting about 2/3. So if it's, back in 75 when 0.14 was measured at the toe of the dam, probably it was 0.09 or thereabouts inside Hyatt. If we're using the 84th percentile of 0.6, Hyatt would probably feel 0.4. So that basically means is that it would feel less, and therefore the level of earthquake that would actually cause damage was probably twice as long as what would be felt outside. So just thought we'd give you the brief information since we got that last month as a draft report. And David Sarkeesian, you can correct me if I'm wrong, but I believe we've charged LCI to do a whole probabilistic seismic analysis of the whole site, so that we basically have the most up-to-date seismic loading.
And we've got the critical curves information for the risk workshops.
Okay, so next steps is that we're going to finalize the identification of needs, objectives, and constraints. And the format that we're using here for task 4 is probably going to be that'll be finalized, and all the other tasks are going to be using that. We'll identify the assignments to complete the evaluations. Like I said, there's about 30 or 40 probably for each task. And identifying potential measures to address objectives. We've already done that, started doing that. We've identified certain things, certain tunnel alignments and certain elevations to consider. And of course, we'll be participating in the upcoming PFMA and Level 2 risk analysis. Okay. Questions? Or are we out of time? Oh, we're out of time.
Any questions?
Well done.
All right.
Did you want to do a little bit of this, like a brief summary of 1 and 2?
Sure. How much
Why don't we
time?
go ahead and-
How much time would you like us to?
We need to get on the road here. You want to just focus on questions?
The 5-minute, 5-minute quick overview?
They're about the same, John. It's, you know, just task specific, but it's to lay out the needs, objectives, and constraints.
And one of the reasons why we selected task 4 is just we spent more time here is we wanted to show this figure right here, this is the process being used common across all the different tasks.
Right.
And so, and if you look at the slides 4, 1, 2, and 6, you see really that similar figure where we're making the needs statement, we're coming up with our objectives for each of those, and then having list and constraints. So that's the process that's common across all the different tasks right now.
Okay. Well, maybe I'll just leave it open for any questions or comments that people have at this time on any of the things we've discussed.
I just want to make a comment that on constraints, and I brought this up, I think, at one of the other meetings, is that I just want to make sure that one of the identified are the constraints to recreation, constraints to the spillway facility, and the other launching facilities around the lake. So I just want to make sure that those are part of the constraints identified. Like, when you say additional physical constraints, recreation. There.
You know, one way that we are capturing.
And I see you existing facilities, maybe that's it right there, but.
Yeah, I'd say maybe I'll start, and I don't know if others have some elaboration. That's one area where, as we're developing the evaluation criteria, one of the categories was this range of other benefits where we're trying to go beyond just the life safety. We're bringing these other considerations, and one of those is recreation. So as we're evaluating different measures, what is the impact that they're going to have to recreation facilities? So I do know that we're capturing that feedback in that way. As far as characterizing as a constraint, I'm looking at I don't know how that works or how our thinking is with that.
Well, sorry, I think, John, the quick answer is that it is captured in the evaluation criteria. And so, and going back to what Bruce was saying, we're trying to capture the positive outcomes of this. So we're looking for enhancements to recreation, among other things, as a part of the evaluation criteria. So it will be captured.
During the 2005 relicensing effort, there was a lot of people that intervened, both government agencies, fishing games, as well as private NGOs and stuff. Are you going back and reaping those inputs that were received at that time and trying to bring those in as benefits to the evaluation process? Not yet?
Bringing those in as far as what would go into, once the license is issued, different projects that we would be.
Going back to this chart here on your public safety, worker safety, regulatory compliance, there's probably a lot of suggestions that came in that were maybe ruled out because of the limitations of the current facility. As we look at evaluating alternative designs, maybe we could reap some of those ideas as secondary benefits and find a way to put those in as maybe additional categories in the evaluation with a lower value of weight.
Can we think that through? Because I think the part that I'm hesitant to give you guys answers or us give you answers right now is recreation is part of our license. So we're going to deal with that with FERC one way or the other. And I just want to make sure that this process, while we do want to look for benefits on recreation or any benefits, we need to do it through this process. But if we get to a point where we're wanting to add recreation or it's taking away current recreation, we're going to go through the FERC process, but this process is going to just talk about how do you meet the goals and objectives that we had laid out up front. So I'm just hesitant on what answer we give because I don't want to make it sound like we're saying one way or the other, but I want to talk to the team on how we, because we're going to go through that FERC process on recreation because it's a license requirement, and we're not going to, we're going to do what we're obligated to do. We're going to meet our commitments. We're in between licenses, so that's another complication, that. So
Yeah,
I would leave it there, but I
Yeah,
don't know.
No, that's fine. I just want to throw it out there.
Well, thank you, everybody, and we'll circulate the schedule for the next meeting and when we would like to get comments back.
Let me take this off first.
Meeting adjourns.